I'll introduce you. Yeah. Good morning, everyone. And good afternoon, good evening for people who are joining us online from other parts of the country. And good morning for people who are joining us from the UK online. Right, so today we are starting our day with our Pro-Vice Chancellor, Professor Kiran Trihan, here giving you an opening speech and inaugurating this day, and also introducing our first keynote of the day. So I will leave some hard work to our Pro-Vice Chancellor. Thanks, Kiran. Over to you.
A really warm welcome, colleagues and friends. I can't think of anywhere I would rather be than here today. Before I start, I just want to say a huge thank you. I want to thank Sonal and the conference organisers, because if there are moment in time opportunities to really think about innovation, to think about sustainability, to think about safe food systems, then it has to be now. We've been talking about this for a decade. So I want to start maybe in a very untraditional way. I want to start by asking a question. What's the common thread between a university for public good, sustainability, food poverty, and this conference? Well, for me, the answer is very simple. They're all underpinned by an ethos of exploration and discovery that makes a measurable difference. So for us, when I talk about how proud I am of being at the University of York, a university for public good, that's in our DNA, it's in our strategy. But that in itself isn't enough. We've known a decade of strategies. We've seen a decade of research, but we haven't seen a decade of work that makes a measurable difference. And so for me, your strategy, our collectivism has to be built around partnerships. But those partnerships have to be built on a commitment to determination, a commitment to really exploring and expanding new frontiers of knowledge, not simply to shape, but to be the shape makers. The global challenges of today and the future are huge, and sometimes they feel almost impossible. And so when I was reflecting, and when I'm asked to give talks like this, it would be easy to rock up, to talk about the university, about the good work that we do. I'm not going to do that. I want to talk from the heart. I want to talk about why this agenda means something for me as a first-generation migrant. I want to talk about why this agenda means something for me as a leader, as a Pro-Vice Chancellor in this institution. But then I want to hold us to account. And when I reflect on this conference, and I reflect on partnerships, and I reflect on a university for public good, the words of a Leonard Cohen song really resonate with me. There's a crack in everything, and that's how the light gets in. So for me, this conference is about shining a light. It's about shining a light on important inequalities, on global challenges that require new kinds of leadership that is rooted in our communities, leadership that is rooted on the ground. And it's how we coalesce and how we use our enabling power and our authority to give that leadership voice. I had the privilege of meeting two very special people this morning who gave me lots to think about, leaders in their own right, you know, one in India and one in Uganda. And they said, how do we develop that next generation of researchers, how do we give voice to communities? How do we put that research to work? In academic institutions, and in organisations, we talk a lot about knowledge exchange. I'm asking us to move away from knowledge exchange to knowledge integration. It's what we do with that knowledge that really matters. So if I'm talking about allowing the light to shine in, and if I'm talking about a different kind of leadership, what is that underpinned by? Well, it has to be underpinned by a collective and sustainable commitment to change, not instrumental change, but systemic change. I have a phrase that each and every one of us can and is a change agent, but collectively we create a critical movement. And so my provocation back to you is, how are we going to create that collective movement? So for me, this conference, the work that we collectively do, our collectivism, our collaboration is not an instrumental endeavour. We are shaped and are shaped by the world around us. Who doesn't want to make the world a better place? Who doesn't want to leave a footprint? Who doesn't want a legacy for the next generation of our young people? But to do that, we have to work really hard on eradicating inequality wherever it is in the world. Today, you're looking at food poverty, food systems that provide equality of opportunity. And so to conclude, there's a crack in everything. That's how the light gets in. It's the imperfections that drive us. It's the imperfections that we use to be the influencers, the shapers, the change makers. But we have to challenge ourselves, because every one of us in this room is a critical advocate. And we have to part our enthusiasm and translate that into concrete solutions. Because otherwise, how will we ever develop solutions, not to people, but with people? So I'm also making a case for partnerships that are critical by design. And by that, I mean that collectively, we work together at the design stage, not at the end process. Because community and community voice is central to that. And so as a Pro-Vice Chancellor for Partnerships and Engagement, you see my energy, you see my enthusiasm, you hear it in my experience. I'm a kid who grew up in India. I was born in India and came to this country when I was 6 years old. I grew up in the back streets of the East End of London when kids like me were told nothing would ever become of us. Education wasn't a right for us. But when we talk about leaders of the future, we talk about resilience, we talk about entrepreneurialism, we talk about dynamism, we talk about innovation. And today, this conference is really putting that work to work. You are putting that intelligence to work. You are talking about and working together in that collective spirit to make not just a difference, but a measurable difference. So I'm going to make a case at this conference that we do things in terms of partnerships with purpose, partnerships that facilitate new and innovative ways to discover, inspire, and innovate for public good. It's got to be manifested in our collective efforts, because we have to create equitable and sustainable futures for all. That's not a choice, that's a right. We have to design partnerships that are designed to be different by keeping public good at the forefront of everything we do. In this university and beyond, our partnerships are designed to break the mould through pioneering education, research, policy and practice. This isn't simply about Russell Group universities talking to Russell Group universities. This is a modern day Russell Group university that is saying, It wants to work with partners that has our sense of shared values, our sense of shared purpose, our commitment to drive change. And then finally, it's about partnerships that make a difference. Changing practices that have far-reaching ways that deliver socially impactful outcomes, not outputs. I don't want us to be output driven. I don't want us to tick the box. I want us to think about what are the outcomes by doing the work that we do. What is the change that we will be leaving? And we can only do that through engaged scholarship, through actionable partnerships, by addressing the problems of our time through real world application. That's what a University of Public Good stands for. This is what this conference stands for. So I suppose my closing remarks here, let the light shine in and let it shine brightly. Make a measurable difference and make every contribution count. Thank you. And now it gives me great pleasure to introduce our next keynote speaker. I'm delighted to be introducing Ian Noble, and I'm delighted for three reasons. You will have seen his bio. So I don't want to talk about his bio. I want to talk about the person and how that resonates with the things that I've just talked about. I talked about leaders that make a measurable difference. Ian has and continues to make a measurable difference. He makes a measurable difference through the work that he does, through the research. We have a shared collaboration. I was at Birmingham University prior to joining York. Ian is a visiting professor at Birmingham University. Ian has led some incredible work on the Agri-Food Tech Leadership Council. He takes those leadership roles and makes a measurable difference. And so without further ado, I'm absolutely delighted to introduce you to Ian Noble, not only a change maker, but a change shaper. Thank you, Ian.
Thank you, Kieran. Not really sure where you go from there. Okay, so let's get a start. So effectively, I think I'm the appetizer, and then the main course kicks off after me. So here we go. So firstly, good morning, everyone. Thank you, Sonal, and to the team for the invitation to speak. And I thought before we dive into the slides and the content, Kieran, you talked about change makers, and you talked kind of alluded in my head to those people that create the cracks that let the sun shine in. Yeah. And sat in the front row here is a gentleman. I'm going to really embarrass Jeff now. Is a gentleman called Jeff. I've known Jeff for yonks. He's gone for full shoes today rather than the sandals. I do love it when you're in sandals, Jeff. Jeff introduced himself to me as a fully signed up sandal wearing physicist many, many years ago. But more importantly, the reason we're here today is Jeff. So for many of you joining in, or for people sat in the room, that'll be like, why is that? But I kind of think, let's not worry about how many years ago it was, but a short time ago, I was talking at a conference in London about reformulation, and Jeff, we'd finished, and Jeff bounced up at the end. I thought about it. STFC needs to get involved in food. And the thing I found so inspirational was we're here, and you guys are all set up with some of the most powerful tools we have in the world to address a challenge that Jeff didn't even see coming, but that knew would be there. So this gentleman can see round corners, and certainly, if I use your phrase, Kieran, and then if I borrow from Leonard Cohen, creates the cracks that let the sun shine in. But I think, speaking from both of our perspectives, we can create some cracks, but we need everybody else to lean into those cracks and to push down, and so that the cracks disappear and they become the sunshine, they become the sky. So that's the invitation, I think, from us all, but just to recognize we're here today because of this gentleman and his vision of how STFC could show up. So, yeah, thank you. And one of the points Kieran made, this is about an innovation space. And I was sat kind of listening into the conversation of the people next to me, and we were talking about the kind of the valley of death, and I was hearing, and I think that's what often people forget. This is not something we have the answer to. this is not something we go, oh yeah, fine, we do X, Y, Z, boof, 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 we know the answer. This is the first time that we, as the human race, need to address the challenges largely of our own making that we need to resolve. So let's not undercall it, but this will be a proper innovation challenge for us all. And for me, it's an end-to-end one. When you get a challenge of that magnitude, it's about everybody, and this is the point Kieran made as well, everybody coming together and working together in partnerships to create the possibilities. It's not all about the developed world showing the way. That will not work in this case, I believe. I believe this will be about us all, and I mean all from a planetary perspective, bringing the best that we can each bring to find the answers, to create the possibilities, to unlock it and to rebuild for where we need to go. So let's jump in, let's get going. So why is it difficult? This is a lovely piece of work from Shift N. And what these folks did was they just looked at the food system and just pulled it, just structured it and laid it out. And if you talk about integration, boy, is this an example of integration. But there's also one of the key parts, because you might look at it and go, oh, it's mind-bendingly complex. You know, well, feeding the human race is probably a mind-bendingly complex and rather important challenge, yeah? But the interdependencies and the complexities, whilst they bring challenge, also bring opportunity, because the interdependencies mean that you can magnify change through the system. And you can make changes in different places and they ripple out. This is not a linear system. The change and the responses that the systems generate require systemic thinking, and that's a different thing for many of us. Many of us didn't learn to think in a systems way, but that's where we need to go to, and that's how we need to look at it. So I think, from my point of view, if I look at someone making a simple change, so let's say that I'm over here and I'm producing bread. Okay, that's great. So if I'm going to move away from using a gas-fired oven, I'm going to move to electric. Okay, that seems quite straightforward. Then you start asking yourself the question, yeah, but at what scale and what speed? Because many of the industrial systems that are feeding people around the world require high heat fluxes. And getting those out of electrical systems is a challenge. The simple answer, yeah, that's fine, we'll just rip them all out and put new ones in. The margins on the food businesses around the world are such that just simply replacing all of the equipment isn't really a viable option. So then the challenges get really interesting. And this from the innovation conversation I was listening to earlier, because this is not simply about, oh, okay, we'll do that. No, it's a highly constrained problem, but then it also creates opportunity. So if we move to lower heat flux systems, does that mean that the ingredient functionality needs to change? Does that mean we need to reach back into the field and see which new ingredients, which new varieties? Does that unlock possibilities there? So the interdependency of the system is, for me, really important. And I think the other point I just wanted to make on this slide, there's only one system on this page, and there's only one planet. So we have to find a way of making those pieces come together and making it work. This is not an option. So let's go and have a look at how we can get into transforming and what the jobs are. This is from the Food and Drink Net Zero Handbook. It's analysis that was done by RAT. So it's about 3 years old. So it's perhaps a little old, but I don't think it's wildly wrong. And if we look at it, what immediately pops is obviously this. So if you think scope 1, scope 2, scope 3 emissions, scope 3 is the ingredients either grown in the UK or imported. It's about, in this context, it's about 65% of the emissions. So that's, if you want to look at it from a net zero point of view, that's about 65% of the job to be done. Packaging, although highly visible, is a comparatively small component, but brings its own challenges and own opportunities. We'll come back to manufacturing in a minute because it's an area I know quite well. If you think about the transport piece, then the question becomes, well, how do we decarbonize? How do you decarbonize road haulage? And there are some estimates that would say in the UK, 10 to 12% of all road haulage is food. Okay, so 1 in 10 of those lorries or more going past you on the motorway is food and drink. And those numbers can be higher. And then you step across to retail, catering, and the consumer. And this is one of the points for me on why I think end-to-end is so important. This isn't a single point intervention. Oh, I fix it in the field, job done. No, that doesn't work. You have to fix the system. And so if we think about what changes will happen here, I think something like the grid mix changes that we begin to see will begin to flow through and have benefit in here. If we move consumers over so they're able, people's homes are using fully renewable, then that starts to change that equation. And again, the same. So I think grid mix has a role to play here. I think as I spoke also, the importance of sorting this one, the transport one out. But then the raw material processing, that really does take us into changing energy sources. And if you're going to change away from hydrocarbon and change away from fossil fuels, then how do you begin to redesign the process to deliver the product that we all enjoy? Because at one level, we're here because we're researchers, but we're also all people, and we eat, and we have expectations for what we eat. In many cases, if we change those products, then you can disappoint people. And then what you can do inadvertently is you see people move away from the products that you've redesigned to products which perhaps haven't been redesigned because they're closer to their expectation. So there is quite an onus, and I'll come on to talk a little bit about that. But we do need to transform across the whole piece. You can't just solve for one or two parts of it. You've got to transform the whole system if you're going to get to net zero. And that's where this framework, many of you will know this and go 6 R's. Well, it's not exactly revolutionary, is it? And it's been around for years. Yeah, but gravity's been around for a while and that still works. Yeah, so that's one of the points I'd say to people. I find this framework incredibly helpful. So just to talk about it, let's just work our way through why I think this is a helpful way to look at the situation. So reduce. Do I change the inputs in field? Can I move to that? Can I look at reducing waste? Can I look at reducing inputs? Yeah, if I go to recycle, then am I looking at what happens if I can move my packaging so I close loop the packaging and start recycling polymers, recycling board materials? If I use to reuse, what about taking some of the waste materials that you were talking about, repurposing and valorizing side streams? How do we begin to think about things and treating them as a precious resource, not something simply to be discarded? If I think about the refuse component, do I move away from fossil fuels and say, no, it all has to be renewable energy? I think about rethink. I think we're going to hear a little bit about this in the session coming up. But if we move, how do we grow? Do I grow in field? Do I grow in fermenter? Do I grow vertically? We have to begin to reconceptualize and rethink how we make this system work. If I look at repair, I begin to think about regenerative agriculture. How do we rebuild soil fertility and through that build resilience? So I think this really simple framework can be used as a compass to guide the work and the exploration and leadership opportunities that we all have as we begin to address how do we transform our food system to becoming a sustainable net zero food system. And when you do that, the important people we mustn't forget are the farmers. Because sat at the heart of this are farmers, small farmers, larger farmers, but all of them need to have a viable business. That's why that's what they do. They're farmers. They make choices. What do I grow? What do I harvest? How do I do that? And we have a point of view. This is us as Mondelez. We have a program called Cocoa Life, which is really looking at cocoa. And one of the reasons that ourselves and similar programs with Nestle and Mars, cocoa is an orphan crop. It's not seen the plant breeding evolutions. It's not seen the agronomy. It's not seen the crop science packs developed. But how do we all come behind that and start to develop those such that the cocoa farmers and the farmers that produce cocoa, because in many cases, these are mixed systems that people are producing, are doing it in the smartest way, and they have access to the best science to enable them to succeed and drive a business profitably for them, because it's their business. So we recognize that we treat them like partners, but we also have expectations of how and what we expect in terms of deforestation, clearly child labour, big issues for us as well that we want to see completely removed. So if farmers matter, so do consumers and customers. And this is a really important part because there are two dimensions to this. Unless you're going direct to consumer, which most companies don't do unless you're a small artisanal provider, then you're working through, in many cases, a retailer. That can be an online retailer, that can be a bricks and mortar retailer, and anywhere in between. But the customers have expectations. They have asks and requirements in terms of where they want to go strategically and in where they want to go economically. So as we do that and you move into thinking about, okay, how do I transform the system? We need to think, I believe, in terms of either renovating existing or innovating for new. And the innovating one always feels a little bit easier, to be frank, because it's a new concept, it's a new space. I can design that to be how I want it to be. Yeah, so if I think about the smartphone, that is how it is. It doesn't have a predecessor in many ways. So I believe the challenge really, if we want to scale what we need to do, is we need to work out how to renovate. And the renovation requires the elements that are called out here, but the key element here is really to remember that at the end of the day, the consumer chooses. So from my company point of view, I can make a change. I could swap out one ingredient, swap another one in. But if the consumers don't like it and they stop buying it and they move to another product that hasn't made that change, I can inadvertently drive to a worse environmental position at a total level than they would do before. So there's an important context. It's important to recognize this isn't just about push. There needs to be pull, and there needs to be an acceptance and a partnership, if I take one of Kieran's words again, across the whole system and build solutions that work for everybody. So what I wanted to do is just say, okay, well, words are interesting, so let's get down to some stuff, shall we? So if I look across here, some of the work we've done, and these are really just to give people a flavour and a taste to say, well, if we can do this, who can do better? Yeah, so I'll take it as a provocation. See, how do you beat it? So how do you make your packaging smaller? You'll notice on Cadbury Easter eggs, no plastic windows, all the rigid plastics. Taking that out meant that we had to go and work with everybody else to say, if we take it out, will you take it out? Otherwise, you end up on shelf not having it and everyone else has, and then guess which way the consumer goes. I know what consumers will say, but when you're in front of that shelf in that split instance, people often go. So that's one piece of changes we've made. I talked about Cake of Life. We have a similar thing with Harmony, looking at wheat. How do we strengthen the wheat producing situation? And we're doing the work in Europe. We're looking to extend that. So how do we bring in biodiversity, and how do we get into soil health, and ultimately reducing down the carbon footprint, improve the sustainability. Taking side skills, grade 2, grade 3 materials. How do you bring those in? How do you use those? In the past, perhaps they would have gone over to animal feed or to others. How do we bring that back into the food system so it's not wasted and not lost? I think about sustainable energy. This is really gaining traction for us. The UK has now also moved to buying sustainable energy. This original example was Australia. So we can move in this direction. And it does bring challenges. I need to think about how I generate steam. How do I generate heat? How do I transform my factory? Because the manufacturing systems have been designed to be as efficient as they can be on the raw materials that we have. And that includes the fuel system. Can we get to carbon neutral using different ingredients? This was a project we ran with one of our ventures companies in France, looking at using legumes, using lentils as an ingredient within the system. We wanted to get the product to ultimately be carbon neutral. And then you look at packaging. So we're looking at about 30% blending back of recycled polymers back into the packaging system. Okay. Oh, I need to stand by the mic.
Oh, we're going to just ask you to use.
Okay, sorry, thanks, Karen. Or just stand still and behave myself. Okay. I may need the mic. We'll see how we go. I'm not very good at behaving. Okay, so let's wrap up, and apologies for those people where I wandered off of my. So where do I think it takes us? So I think it takes us, and I mean us. So that's everybody, and that's the invitation. We have to learn to design, and I think Kieran touched on design as well, because design opens up the possibilities. Design invites people in to say, how would you do it differently? Why can't it? It's a very creative way of looking at the situation. And the great thing about food is that it's so broad that there's space in here. This is a big enough house for everybody to come and engage. Whether you're doing extreme generative AI, whether you're in crop science, whether you're in material science, it genuinely doesn't matter. Microbiology, literally. Think of a discipline, and I'll bet you we can find a place that they have in this challenge. So for me, it's about moving to end-to-end product design, because you have to think from field all the way through to the consumer and beyond. How do you close that loop? People may have noticed there's no off-take for the planet. Yeah, it's all done on the planet. So end-to-end product design, that needs to go all the way through. It needs to include shelf life. Yeah, so yeah, we can take, yes, so people will say, well, take out plastic. Okay, fine. Carry your chicken home in the paper bag, see how you get on with that. Yeah, we need to be smart, but that's just me being flippant, but we need to find smart solutions that enable us to preserve shelf life, to minimize food waste, but still get to where we need to get to. There's no optionality here. We have to find the solution. that has to fit consumers and customers. And then from my point of view, we're looking increasingly, we look at scope 1 and 2 on the greenhouse gas side, and we're now starting to think about the water questions, about embedded water, about green and blue. And for those of you who haven't looked at that, that's really worth a think and a look through. There's some very nice detailed information now coming forward. But it requires everybody to really understand food systems. So I would encourage everyone, take the time to just get a little bit inside the food system. Don't see yourself in one part. By all means, focus on one part, but see the whole. And really, that's where we need to get to, because if we can understand what we need to do, then we can transform the food system. We can build it to net zero. Because to do that, that's where we need to go. That is the challenge, and that is the innovation that we need to address if we're going to achieve the transformation. And we can stand here and talk ad infinitum, but the people that will make that change are us, all of us, not one or two. It's not a question of looking at the front and thinking, yeah, that's great, I hope he gets on with that. It's about looking around the room, looking across with colleagues and others, because it's all of us together who will find the solutions to questions we haven't even identified yet. So that's, I think, the challenge for all of us. And the talks that are coming up, I think, are fascinating examples of how we can begin to unpack that, bring new solutions and new opportunities. So thank you very much.
Thanks, Ian. What an inspiring talk, and what a good way to kickstart our day. So now we have our theme 1 presentation of this particular day. So I would invite Jens and Hugh, who are our data science champions and liaisons, to kindly chair the sessions. And please look out for any synergies that is coming across with your research, and we can take this up during our breaks. Thank you. Yeah.
Thank you very much, Sonia. So if this is the main course, then Hugh and I will be serving it to you. So our first speaker is Dr. Daniel Evans, Cranfield University.
Very good morning, ladies and gentlemen. Am I standing in the right place? I hope so. It's wonderful to be here. Thank you so much to everyone who's come and networked face to face for the first time. That's actually really important, I think, for driving that change that's been talked about this morning. And just to say that after yesterday's presentations on honey, it seems like we've already made some impact, because I was at the breakfast bar this morning and saw no golden syrup. So we're making changes faster than we think. So it's great to be here. My name is Dan Evans. I'm the PI of this proof of concept project that was funded last year by the STFC Food Network. And I'm really pleased to be able to present some research that we've done on behalf of not just a research group, but a collaboration which has involved policymakers and industry as well. That's really important. We started off with 3 main challenges, which are kind of identified at the top of this screen. So the first is a distribution. In urban spaces, and that's the context of my talk this morning, the food growing is very limited. There's obviously an increase in population and a burden on space, and this leads to only 1 or 2 sites being used for urban food growing, and as a result, an overworking of natural resources. Functionality, sites tend to be used just for cultivation, which means that other critical parts of the food supply chain are not addressed, which means composting, waste collection, food exchange, vending. We saw that 5% for transport emissions in that talk previously. Things are often exported out of the urban spaces. And third, many food growing functions displaced beyond the town or city. So we create sustainability challenges. So what we've done in this project, in a sense, Urban Cultivate, is take a cluster of underutilized spaces, vacant spaces in a city, and analyze them, use this data to designate these spaces with new urban food growing functions. And what we hope is that together, by bringing all of these disparate spaces together, we can create a local self-sufficient food supply chain. So a whistle-stop tour then through the methodology. We've concentrated on Islington, one of the densest London boroughs. Almost a third of the households don't have a private outdoor space, and yet there are 57 acres around the housing estates for public use and not really doing much at the moment. They are in many cases passive spaces. They're photographed on that satellite image. And what we started to do was shortlist 100 of these sites around the Tufnell Park ward and create a cluster, a 5 or 6 site cluster of these spaces. We then collected site data. So we went to these spaces, we went online to gather satellite data. We acquired spatial geometry and volume data for the spaces. We also went in on the ground to collect data on the microclimate, the air quality, the soil quality, and so on. We realized that some spaces may be hopeless for food growing, but brilliant for food exchange. And then we used STFC data science capabilities, working with University of Sussex, Peter Hurley and Joseph Starkey down at Sussex, to design an optimization model. So this model basically takes data from all of the sites that we've studied and finds the best use of those sites, one of the functions in that food supply chain, from waste collection, composting and soil formation, all the way through to cultivation, gestation of seedlings, and then finally food exchange. And as I said before, realizing that some sites will be good for one of these functions and maybe not for another. So we use this model to calculate the suitability value for different food growing functions. And then we've created a dashboard that hopefully presents this more accessibly for the public. And that is where I kind of conclude. So the engagement with stakeholders is so important here. It's nothing that we can't do. We know how to integrate and engage with stakeholders. So we've communicated with the local community, food growing groups, the residents, the businesses in and around the Tufnell Park ward. We've given evidence to the borough's Environment and Regeneration Scrutiny Committee, and we've had multiple follow-ups with policy makers in that area. And importantly, at the moment, there's a right to grow food bill working its way through the House of Lords. And we've been identified as one of the case studies to showcase the wonderful things that can happen if we use vacant and underutilized spaces in towns and cities. And of course, we're engaging more widely across other towns and cities. And I think in terms of future ambitions, where Urban Cultivate now goes is to upscale our model and to develop a commercial service out of this. So we're in talks with Arup at the moment to optimize in a very similar way to Islington, the underutilized spaces within Lambeth. And we really want to use STFC capabilities to advance that scale. We want to upscale this within Islington. Islington wants us to stay, but we've also mobilized local mayors across Europe as well. So I think there's a great opportunity to work and scout out some additional funding. So that is it for me. Thank you very much. And if you'd like to hear more about this, please go to our website or contact me on these details. Thank you.
Thank you very much. And next speaker is Professor Chung-Wei Liu from. Okay. Okay. Yeah. Sounds good.
Okay, so hello everyone. My name is Gadar Hag Mohammed. I'm working for about more than 3 years with Chung-Wei Liu, and I will present Chung-Wei's presentation as he is not in today. So this year we don't have any fund from the STFC project, but I will talk about the project that we had last year with Chung-Wei Liu group. So it's basically about increasing the nutrient use efficiency and the crop productivity of hydroponics using smart sensors. This will be including the sensor that measure the ions concentration in the hydroponic water and the 3D multispectrum scanner that used to scan the planets to give more than 12 different parameters to give us about ideas about the plant growth performance under each different conditions, including light and nutrients concentrations. So I will start with the food challenging. So as we, most of us know, the challenging that facing the food supply chain, I will say in general. So the most challenges we are facing now is poor weather, where we are facing a problem with climate change and different things related to this matter, and also the higher cost of the laborers and the people that are working on the field and providing the food, specifically the vegetables and fruits, which increase the cost of the supply, as well as we are use a kind of inefficient way for using the suppliers, including the water supplies and different nutrients that will be used for the growing process. So also we need to mention to the problems that we had facing last year and the year before during the corona pandemic in the UK and some other European countries as well. So as we can see, one of the options that are available now as one of the topics that we need to discuss is the vertical farming. So this project was mainly focusing on the vertical farming as one of the options that could be used to solve the problems in the food supply chain and doing some different way to tackling the problem we are facing at the moment. So the vertical farming basically is a kind of soilless environmental to grow vegetables and fruits, specifically the leafy vegetables for now. And we try to use the AI techniques as well to try to enhance how we can manage the using of the nutrients that will be added to the hydroponic waters, as well as to know what's the suitable light conditions that we need to provide to the planet in terms of use efficiency of the energy to providing these light conditions, as well as to try to reduce the time being these vegetables or leafy vegetables be ready for harvesting. So instead of, for example, taking like 2 months, 2 months and a half, we try to reduce that by using different type of light conditions, including different light wavelengths and light intensities. So the methodology we used basically is all about finding, I would say, award recipes for the nutrients and light conditions that we need to provide. So this will be include using different IoT technologies where we collect our own data that are presenting different parameters, starting from the environmental conditions parameters and go to the light conditions, as well as we try to calculate the uptake amount of the nutrients during the experimental, what is the plant growth in the hydroponic systems. Also, we'll employ different approaches of AI to try to understand and train different models to predict the optimum recipes that we are looking for, as well as we'll use the 3D multispectrum scanner machine, where you can see it here somewhere there in the corner of the slide. So this is the 3D scanner, can be able to scan as much time as we program it for this, the plants to give us different parameters about the plant growth performance. So we can see what's the plant response under each of those different conditions and the treatments we provide. And here we are using the indoor growth facilities. So the result and impact of the project is basically the first step is to generate as much big data as we can that collected from the sensory devices we used. So this data will be used later on for improving the AI models that we already used. Also, we are planning to use different AI machines and machine learning algorithms to predict and optimize the optimum growth conditions, including both the light conditions and the nutrients specifically. And also we will use the STFC supports and construction of a cloud computing system to save and create a kind of online platform for these collected data set and developed algorithms. So here's some images from the tomato experiment we had last few months, where we use different nutrients concentration that delivered by different AI algorithms, plus to different light conditions. So this growth has been compared with the normal growth conditions, including the one that already used, and the results obtained from both different experiment was really promising comparing to each other. So here we are more focusing on the using of a nutrition, which is the NPK, which is the macronutrients that we will add to the hydroponic solution water. So we try to calculate the use efficiency of those different NPK ions. So we can see in the first week and first 2 weeks of the starting experiment, we be able to save up to 48% of the nitrogen and about 45% of the potassium. So the next step is validation our own recipes by undertaking different experiments and also apply for different funding, including DEBRA and STFC for industrial. And also we will do further investigation to improve the current AI algorithms we already trained and use. Thank you very much.
Sorry to hurry you up with that's the name of the game. So our next speaker is Professor Peter Ball from the University of York. Peter. Thank you, Jens.
I'm really grateful for the last two speakers on this, because conceptually this project takes a bit of both of the last two projects and brings them together. So the project is about urban vertical farming, and as an advert for the city, if you've got time and you go back into the city and you've got time to wander around, there's a place called Spark York. Go and visit it. Sorry for the online people, you can visit it virtually, but Spark York has got a farm that we centered this case around. So we were looking at data models and optimization for urban vertical farming. So we wanted to look at locally, what can you produce, but more importantly, how can you feed those farms, and what can you do with the wastes in the local area. So Jens was part of this project, Iffy was part of this project, and a number of other people. So on this food challenge side, the emphasis I'm going to put on it is all about local. So we were wanting to look at how could we move things around locally, and can you do it efficiently, and what are the technical challenges. And we were working with Jens at STFC to help us with the data modeling, the data access, and number crunching that data. So we wanted to tackle urban waste. We wanted to see if we could use it for local benefit. And one of our challenges was that we could get lots of data in certain areas, but other data was quite poor. So we wanted to have a look at that as well. The diagram at the bottom, the bits in grey, I'm going to arrogantly say we know already. We don't. We need to know a lot more about each of those boxes, about capturing data and new materials. But our bit was all about the glue of how to bring these areas together. So we wanted to see what data we could capture and move around. I'm going to focus on two areas. One is feed, the number one, and number two is construction. So on the feed side, we worked with IntelliDigest, Iffy, on looking at the nutrient flow. So that was with SRUC as well. And we wanted to know more about what we could capture as nutrients for feed. And the other areas was construction, where I ended up going to a brewery in the yard, shoveling a spent grain and putting some warm substance in the university post and hoping they would take it, which they did. So we converted spent grain into bioresin and created a sample of board that potentially could have applications in construction. And the farm, the Grow at York, the pink thing there, is what we were building the case around. The brewery, Brew York, is about 100, 200 meters away from the farm. So we were trying to locate things close together. And importantly, there's lots of local businesses that are making money in the city centre. So why can't more businesses, and why can't we have more economic activity locally? The results and impacts, we investigated more about the feed cycle, as I just said, the construction cycle, and we created two models, one more of a logistics model of moving material around a local area, but on a freshening side, we also looked at how long can you store some materials before they degrade. We created some videos. The top right QR is a video for the project. The bottom right is a video of a presentation about the project. And we did lots of presentations generally. Importantly, we've moved on to other things. This project ended a year ago. So we've made a couple of starts on some proposals, and we want to keep on going at those proposals. It was a really good consortium. We've quite a diverse group that most of us hadn't worked with before, but we found ways of working again. There's one project where we're looking particularly at the materials and working with a constructor of vertical farms and seeing whether not only can you use them in new materials, but could you redesign the farms or design the farms in a fundamentally different way. And I'm looking at my phone and I'm thinking, thank you very much for your time.
Thank you very much, Peter. Our next speaker is Professor Katwa Sugiarto, who has come all the way from Indonesia just to talk to us.
Well, very good morning. This is a collaborative work of the three institutions. I'm from Gajah Mada University, UGM in Indonesia, and then also from the Newcastle, I have Diogo and also Alisa, but she's not here. And also I have Jens here. Thanks to STFC for bringing us together for this wonderful opportunity. And this is a special event for us after 3 years of, working together online, and then finally we met here. As a common practice in agriculture, we do some division of labor. Lily is supposed to be, presenting and also answering the question, but now I will present the result, and then I think Diogo and also Jens will take the question later. Okay. The main question that we try to explore is whether urban farming can contribute to food security and also vulnerable urban dwellers in southern Asia. This is in line with the current research, and whether urban farming can help urban vulnerable population, whether they can provide incomes and so on. So we documented whether what is the produce, and then where and when the harvest and the planting, the vegetables and also the flowers, and how and at what scale the production for each of the household. So overall we combine the data, economic data, and also the social science information, and also digital technology that we describe the Yogyakarta, which is the case for this research. And then try to ask the question, do urban farms really contribute to household food security and also incomes? And then what kind of products that are produced in these urban farms? And then are there any special pattern of production, different area, whether they have different products and so on. And then whether we relate the production with the current problem of stunting in our city, whether this urban farming can contribute to that stunting problem. So what we do, we try to map the data from the household survey, and And then we try to combine the data later on with the standing information coming from the office of the health center office actually in the city. And then we try to characterize the urban farming. For the sample, we cover about 10% of the total farms member of the members of a farmer group in the city. And then we work closely with the extensionists because that was the COVID during the survey. So this is one of the results that we have. So at the left-hand side, we have a fruit and vegetable production. The circles picture and the size of the production, and then the different color showing different types of product in that specific sub district. So here, for example, at above the northern part of the area, they have a big size of the vegetable and fruit production. And then on the right hand side, we have a fish and livestock production. Again, in the southern part of the city, they have a bigger circle. Then they're showing that most of the fish are produced in the southern part of the city. So again, we look at the specialization and the dominance of the product that the farmers use, whether they're showing the different preference of the production. And also we try to relate the characteristic of the region, whether is it the city, I mean the part of the city close to the city center, or is it close to the local farmers and so on. So that's might influence the characteristic of the product that the farmers have. And then well, this is a one time of survey. So if we have a chance to extend our research later on, maybe we can do the same similar survey and then look at the dynamic of the picture, looking at the flow of the product, the marketing, and so on. Okay. So that's what we looking for later on. And then overall from this survey, we found that farmers are happy because they can sell the products to the neighbor, also to the local traders, and also they can give to the neighbors, and also they can do it for the own consumption. And we also observed that there are some specialization, like in the fish production, certain part of the city, most of them produce fish, and also the northern part of the city, they have more vegetable and also more flowers. Most of the farmers are mothers, and they are very happy because they can contribute to the income of the family. And then also they are happy as well because they can work together with the neighbor, because during the COVID, many people work from home. Then they can do the farming and then also share the product with the neighbor. And for us, we are happy because we work closer with the local office and also local NGO, especially the Young Farmers NGO, that help us to do the survey. So next, we're looking forward to have discussion with the local policymaker, whether so whether we can take this result to help them to design the policy about specializing the types of product for certain area, and then help the family who have a standing problem, and also the marketing of the product. So that's about all that we have. Thank you.
Thank you very much, Kajol. So next we have the report from the Vertical Farming Expert Working Group. And to be honest, I don't know who's giving that report.
Good morning, everyone. I'm here to talk about these new networks. We started a couple months ago. We had quite a slow start. However, now we have kind of have some ideas to progress in the future, but probably we need your help. So originally, this group is called vertical farming, but you know, some people really hated the concept of vertical farming for some reasons. For example, very high capital cost, energy intensive. I know Sonal did previous work look at control the environment. So I'm thinking probably we try to kind of improve the scope from vertical farming for this expert group, from vertical farming specifically, but move to more control the environment or protect the environment. For example, polytunnels, vernacular, low-tech technologies, but it's very efficient for the new vertical farming kind of concept, which is in the urban area, how we can grow food for the ever-growing urbanization trend. So currently we have 9 members from different universities and some commercial organizations and different networks. And my name is Yan, and my background is building services engineering, so heating, ventilation, lighting. And Esther, she is from the fishery aquaculture. So that is something we like to incorporate. So obviously, vertical farming, aquaponic, that is something always combined together. As I said, we had a very slow start, but we managed to develop some workshops among our expert group. We talk about challenges for what we can address, urbanization, spatial, energy, technologies, and why it's important. So I think the people attended our workshops are generally interested in sustainability. For example, food waste or zero carbon transitions. I think that is possibly the focal point for this expert network. And we developed a survey, so it's an ongoing survey. So this is a barcode and for you to engage with us. Please scan if you're interested to engage in our future online webinars. So we, between Paulina, Sona, Aisha, and myself, and Nan, I see few raise their few of our committee members will try to develop a kind of bi-monthly webinars if it's possible, and have developed some kind of list. But possibly I'll try to email some of you to give webinars for us in the future. Which some initial results so far for this survey. So this is all the same barcode for the next 3 slides. If you're interested in engage in this network, please just scan in. So we ask people what is why you're interested in vertical farming. So the people have sustainability, decarbonization, hydroponic, alternative fertilizer. So that is quite interesting. So vertical farming is, sorry for the typo on the top of the title. It's not purely you can see on the vertical farming for the LED lighting driven technologies, but it's more on the other aspect as alternatives for conventional farming technologies. And what activities you would like to see the group or to organize. So you can see quite a few people mentioned about controlled environment agriculture. So that is also reinforce our understanding vertical farming is really, for us, is more about controlled environment rather than have to put on vertical farming or LED lighting. But it's one, obviously, innovation approach, but possibly how way to renovate, as mentioned, is existing growing polytunnels for the productivities or sustainable agriculture. So last question is, do you like to present in the future? So people talk about circular design, resources efficiency. So there's quite a few we have 3 potential kind of speakers for next kind of webinars. But if you guys interested, please get in touch and we're happy to organize webinars. Like I said, we don't cost anything. Webinar is free from team. Okay.
Very much.
Thank you. I guess I should remind everyone as well, if you have a burning question, you can use the Mentimeter for people online and indeed in the room. So next we have another report by an expert working group, this time on remote sensing and AI, and this one is given by Jens Jensen.
Thank you very much, Hugh. So I will now need to nag myself when I run out of time. So what is the challenge that we're trying to do in the working group here? I should say that the working group is led by Guy Zhu, who is from the University of Leeds, but he couldn't be here today. So I'm sort of filling in a little bit from my experience with the previous projects as well, although the group, of course, is looking forward. So I'll try and cover things we've done in the past, as well as stuff that we will be looking at in the future, so projects we'll be working with. So the whole point of this is to have sensor networks out in the farms, in the fields, in the forests, whatever, that gather data, and we want to process that data. But you don't want to have your phone going bleep, 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 I'm fine, I'm fine, I'm fine. You want to have the phone telling you when there's something that's wrong, that you need to intervene. As a farmer, you want to go and check up on your bees or whatever when they need attention, like when you need to look at things. So it's all about data processing. How do you get the data from the sensor? How do you make sense of that data? How do you pick out the stuff that's important? And this is where the AI aspect comes in, as we'll see. I will be talking about gathering data and intervening in these things, but there's actually a wide range of activities covered by the projects that are participating in the working group. They're looking at monitoring or modeling greenhouse gas emissions, the health of the soil, carbon in the soil, moisture in soil, flooding in the fields. So you could essentially take that data set that you get from the farm and turn it into a digital twin eventually. Because you can say, this is what my farm looks like, and I can see a field is getting flooded, and you can try and do something about that. So I want to pick up a couple of past projects that I have been involved with. So I wanted to pick up the Miying shrimp. Miying was looking at aquaculture in Indonesia, and Paulette's bees. Paulette was interested in beehives on the Harvard campus. And both of these projects have something in common, that they have sensors that sit in the pond or on the beehive, and they gather data, and we want to make sense of that data. We want to gather some of it for analytics. We want to gather mostly things just to like alerts. Something goes off, the pH value is wrong in the water, or the bees are unhappy because they're doing something, or the bees are on strike or something, or you want to know when they start swarming and stuff like that. So one of the problems with this is the general outline of this looks like sort of a scenario where you have measurements and you sort of filter them up. But the trouble is that we don't have enough bandwidth. So going out to the beehive, we started thinking, could we have a camera that looks inside the hive to check how the bees are doing, what their behavior is, if there's anything visually wrong with that. And we couldn't, because we just didn't have enough bandwidth. So in a production environment, that intelligence of processing those images will have to sit with the hive. And there will be a solar panel or something that gathers enough energy to run the processing of that data set. And then we can process just a single bit of information saying, I'm happy, I'm happy, I'm happy, oops, something's wrong. So that will enable the farmer to have a beehive in more remote locations so they don't have to check on them all the time, because the sensor is doing that, and the sensor is intelligent enough to find out whether something is wrong. So this is also where the AI comes in, that if you're doing vision processing of this information from the camera and try to identify where the bees are and what they look like and how they're feeling, then that we just need to communicate the result into that. And at the same time, we had a little memory card gathering the data from the Hive, so we could come out and plug out the card and actually get the full data set that we can then use for further training of stuff or similar things. So that's kind of how it is. You process data close to the edge, which is how the edge computing terminology comes in, or even fog computing, goodness me, with like a distributed cloud, right? So you have the data that comes in from the sensor networks, but it comes in a smart way. They only send stuff into the farm that you need to know. And then we can process across farms and gather stuff in the cloud for research or for comparing notes across the farms, saying you have disease in that farm, or there's an adverse weather event that affects all the farms in the region. And that is it from me. Thank you very much.
Thanks, Jens. So our next speaker is Dr. Melina Zempila.
Hello, good morning. It's always a pleasure joining SFN's events and see how strong the network is growing through the amazing research and presentations we watched today. And I'd like to thank you for hosting me today by presenting the small proof of concept funded by SFN last year. RALSpace, the National Institute of Agricultural Botany and Scientific Remote Sensing, have joined forces in this small project for the past few months, aiming to track rust. This project has a quite long and descriptive title, as you can see, but I'd like to call it by its nickname, rust spotting. So the aim is to identify yellow stripes on wheat plants by static and aerial hyperspectral imagery. Not too long ago, our wheat yields have been threatened by a global spread of genetically modified yellow rust, which has highlighted the need to monitor and assess the health of our crops. A response to this need comes from rust spotting that aims to early identify yellow rust as a mechanism to alert farmers and agronomists. To achieve this scope, we have designed two different but interconnected experiments. So with the knowledge that we acquired by hyperspectral static imagery in the lab at different stages of rust disease development, and the detailed information we got from spectra in the visible and near infrared, we are able to feed this information into our classification algorithms that take advantage of the information from our moving platform. And in our case, it's our hyperspectral imaging system that is commercially available on our drone. Here you can see on your left-hand side, the development of the reflectance, the increase of the reflectance value, while the development of rust disease is growing on the leaves. So from day 1 to day 25 from the inoculation date. And you can also see the detailed spectral information taken from healthy and infected samples in the field, which clearly manifests down at the bottom that there is a distinctive spectral region where the reflectance from the infected samples is significantly higher from those coming from the healthy ones. With this information in mind, we have developed different classification algorithms that take advantage either the full spectral range provided by our hyperspectral system, all 41 wavelengths, and you can see the fuzzy clustering on the top hand side. And we also have developed simple differential approaches by taking spectral ratios over distinctive spectral wavelengths provided by our images. Which of the approach is the best? This is yet to be defined, as we had our last campaign in June, mid of June, so I'm processing the data. And we have just received the ground truthing for the validation of our classification algorithms from our partners at NEAB. So we will shortly have our final results, but it's worth mentioning that we have some interesting and encouraging results from the graphs that I've shown you before. Thank you.
Thank you very much. Thank you. So now we have another expert working group report. This one is on standardizing LCAs for proteins. And again, we don't know who's doing this. So hopefully it is brilliant. As you're there.
This is.
Have control over this.
Yes.
Yeah, everyone else, you just need to stand here.
Yeah. Sorry, I had the old schedule. So actually, the next talk is by Iffy. Sorry, that's it.
Hello, I'm Ife Yomokano. I'm the CEO of IntelliDigest and also a champion of the STFC Food Network. And I'm very pleased to present the project we did.
Is the people working? No?
Okay, fantastic. Just be slow. I'm sure I'll get more time. So the project was quite encompassing. We had a lot of core-eyes in the project from different universities, as you can see. We also have the STFC side core-eyes too. Dr. Jens Jensen, who you must be very familiar with by now. Sarah Roger from the Center for Laser Facility, and also Claire Pizzi. So what were we trying to solve? A lot of these statistics, we've heard about it as we heard a lot of presentations yesterday and today. We've got a broken food system, over 900 million people are hungry, we waste over 1.3 billion tons of food. It doesn't add up at all. So how do we really help to close this gap? And I think some of the presentations we've had today with regards to Dr. Ivan's presentation around urban systems and also the vertical farm circularity, all get towards solving the same problem of ensuring that more people have access to good food in a way that doesn't hurt our environment, but also improves our health. So that's fundamentally what we try to do in this project. So we had key tasks or milestones that we set out for ourselves when we started the project. So one of the key things we wanted to do was look at collecting data on available food waste across the country. We also try to look at how we can recover these bionutrients, how we can use it in food production, and what is the consumer's perception about food produced using this. So really very wide, but I think there was a lot of commitment and passion trying to do this. So the technologies we use covered different disciplines. So we looked at enzyme engineering, green chemistry, big data analysis, sensors, artificial intelligence, and also photonics. So what did we do? We work with SLF and we try to explore different spectrometers to analyze the food waste. So that when we identify areas of food waste, we developing a machine to be able to upcycle it. So we call it robotic bio-upcycler. It's kind of nature driven. The only way I can explain this to you is that the way we eat food. So when you put food in your mouth, the food you put in your mouth, you have enzymes in your mouth from your mouth that understand what the food is and then start breaking it down. And this is how most biomaterials are broken down, whether using microorganisms in biodigesters or anything. So what we're trying to do is, rather than using microorganisms, because you need to optimize the environment for the microorganisms to thrive, we start to use that enzyme that they produce by optimizing the environment for the enzymes to thrive. So which means that the system can be on and off, so you don't have to really continue to run a system because the microbes need to be alive. So optimizing that process means that you understand what the composition of the food waste is, and then when you understand the composition of food waste, you can do the right amount of enzyme to optimize the process, which means that you also having a higher volatile solid reduction, because a standard biodigester have less than 30 to 40% volatile solid reduction, but with enzymatic biocatalysis and optimizing the process, you have a maximal breakdown of the biomaterials, which means that you have more nutrients for plants to uptake. So that's what we're trying to do with this. So by understanding the composition of the food waste, we can dose the right amount of enzyme compositions are defined, and then we can break down the food waste and make it available for plants uptake. But we also did a work about trying to collect data and mapping the economic impact and also environmental impact of trying to move those food waste around and also using it back into food system. We actually did a project trying to use bionutrients from the food waste to grow lettuce germ. This was done by CHAP, Crop Health and Protection, and showed one of the key things that came out from this is the bionutrient from iDigest has got more nutrient content in terms of macronutrient and micronutrient in the food produce. So that was really a very positive thing for us from the project. There were some things that need to be improved in terms of the salinity, the salt content of the output, but that's something that we already know we have to work on. So what's the impact? We need to make this food system work better. We need to improve the we need to look into the input. I mean, this is really a critical issue with the current situation we have today. When we did this project, there wasn't a massive increase in the cost of fertilizer, but after this, there's been massive increase. So, we need to not just because of the environmental impact, because of the health impact, but also the economic cost of the input. So we have to do that. We have to close the gap. So what have we achieved from this project? We've got this machine, robotic bio-upcycler. It's nature driven. It's just based on natural process of enzymatic biocatalysis, but more of using sensors to optimize the process. We also have the workflow tracker platform, which currently is being used across the globe. So I will encourage anyone who is here today, just put in your system, your Google or wherever search engine you use, www.workflowtracker.com. spot on, you get on the platform. Please spread the message. It's really impactful. It's helping people across the world. Think about the food they eat, because the future is about consumer-driven production. We need to really enable consumers to drive the production to ensure that we meet demand and supply and we have less broken systems. So we need to expedite action. We need to do something now. And I'm so happy that everyone in this room, we're all doing great things to help the food system. And we encourage you to continue the great work you're doing. Does anyone who can help you at IntelliDigest? Please feel free to shout out. Thank you very much.
Sorry. Okay, so I think the last talk of this session is again a small change in the schedule. So this is going to be presented by Sun.
Yeah, I'm just going to see if this is the right presentation or not. Policy engagement. Yeah, that's the right one. Okay. So I promise I won't be long. But I can't promise I will be exactly 5 minutes, because I'll give 5 minutes to Jansu. So Jansu. She has done some really great work with digital twins, along with our STFC colleagues, Tom Kirkham, who's no longer with STFC, but now he's with Innovate UK. And thanks to Jeff for bringing us all together with Food Standards Agency. And we did some fantastic brainstorming exercise of what is needed in the policy space and what we can do together as a team. And these are our team members from Ray, Victor, Jansu, Rakesh and Ray are here in this room. So if you have any difficult questions, they are going to fetch this. So we normally run quite a lot of sandpits in STFC Food Network, and through COVID, we started running quite a lot of virtual sandpits, but this happened just before COVID hit us. So there was an opportunity of bringing people together from Food Standards Agency, about 40 to 50 civil servants in STFC Hartree Center, with 30 to 40 people from agri-food, data science, technology coming together, working and co-developing projects with civil servants and co-designing some of the small projects which could go and make some difference. So the main challenge which was asked from SFN to look into was from Professor Guy Poppy in one of the conferences, where he said that, you know, till now we are quite Victorian when we are doing our food inspections, and especially meat health inspections. So can you guys from STFC, can you look into and help us understand how do we make it 21st century food inspections? So what we did next, we did quite a lot of visits, abattoir visits, food factory visits, and we did a very in-depth review from all the different varieties of meat products you can think of, what is being done at the moment as is model, and what are the different processes and different technologies that can be combined together to make it a bit more 21st century. Then we had wonderful sandpits in STFC Hartree Center, where we were looking into UK meat industry, which is about 4.4 billion a year economy. So it's generating quite a lot of income for the UK. And looking into what we can do. So one of the projects that we did through the sandpit was understanding the digital simulations, the digital twin of FSA's inspection, the as is, the way they do the inspections now, and the future that they could be doing the inspection. And when I'm saying digital twin, that could be actually applied in literally any field. So we have done it in the inspection, but we could also do it in, let's say, digital twin for UK agriculture or agriculture anywhere else in the world, how that would look like. So just to give you a little bit of glimpse of this, has already been now accepted and published on FSA's website. Feel free to have a look, and the details of the reports are already there.
In this presentation, I'll give you a brief introduction of a digital simulation technique called discrete event simulation, and I'll show you a use case of this method in a generic abattoir environment. Discrete event simulation is a method of mimicking the behavior and performance of a real-life process facility or system. It can help making informed decisions by analyzing process flows, finding inefficiencies, and evaluating the processes. It provides a virtual testbed to explore what-if scenarios, hence making the right decisions before interfering with the real-world system. These models can be animated in 2D or 3D, allowing concepts and ideas to be more easily verified, communicated, and understood. Moreover, uncertainty in operation, process durations, and outcome can be easily represented in these stochastic simulation models, which allows you to measure risk and find more robust solutions. We have awarded a project through Science and Technology Facility Council to explore improvements that could bring the meat industry from the 18th century, which is their current rate of operations, to 21st century and make it traceable. In the context of this project, one of the main objectives was to simulate an abattoir environment that involves employees, veterinarians, processes, inspection points, and technology for inspections at antemortem and postmortem stages. We use this model to explore what-if scenarios to assess the implication of new technologies to predict their benefits. So here I'll show you a video in order to make you aware what the model looks like. Our model consisted of a user interface where the input variables such as the livestock batch size and arrival frequency can be altered. Durations and capacities on antemortem operations can be changed, and some automation opportunities on post-mortem operations can be played with. For example, automating the stamping process, which will decrease the duration of stamping of one carcass, and using image detection AI technology to help with FSA inspection are the variables that we included in the user interface. Well, of course, in the context of the project, we limited the number of variables that the user can play with. However, these user interfaces are bespoke. We have a logic window where the process flow involving the people, machines, and the technology is modeled. Even on this window, it is possible to keep track of the carcass movements and utilization of resources. It is more like a live process flow diagram. A 2D and 3D animation, which makes it easier to follow the movement in the abattoir environment, is also included. For example, here you can see the arrival of the trucks in this part carrying the livestock. You can observe the layrich area. From the layrich, livestock are moved to antemortem operations such as gut stunning. Then the carcasses follow the postmortem operations such as bleed out, dehairing, various inspections, and the end products are stored in the chillers for about 1 day. Here you can see the various parts of the simulation model. Finally, you can see a runtime KPI dashboard where the performance measures such as utilization of employees, veterinarians, efficiency of the operations, and the throughput can be observed. Of course, the dashboard can be altered regarding the need of the stakeholders. I would like to thank you for your time, and I'm Cansu Kandemir, and I'm a technical lead for digital simulation. Please feel free to contact me through email for any specific questions. Thank you.
Yeah, more information is there on the YouTube as well. So Ray and myself, we presented a webinar for FSA on again unlocking the food chain information that is currently on paper at the moment, and if we digitize that, what could be the business implications for that. So with that, I will end this talk, and yeah, I invite you all for the questions now for this team. Thank you. Oh.
Yeah, so can I just add something to what you just said? So the journey for that one started even before the Food Networks started in 2014 with conversations with Guy Hopping. It takes that long to get through the door to get things done, doesn't it? And it's just, you've got to still be tenacious, and it's a lot of patience. Patience.
But it happened, so that's great.
I'm so pleased to have.
Can we have all the questions?
Yeah, shall we do what we did yesterday and have all the speakers from the session just come up and stand at the front, and then whoever has questions for you can ask them.
And feel free to grab a cup of coffee, remaining cold coffee, but hopefully we should be having lunch in about 40 minutes now.
So should we start? Does anyone in the room have a question?
I have a question to the Rust monitoring.
Yeah.
So I think the trait you're looking at is the chlorosis in the leaves. But given that many conditions including nutrient deficiencies cause similar symptoms. How have you found a specificity for that in terms of the ratios that you're looking at? Or I just want to understand how you are actually making sure that it's specific for the rust.
Yeah, sure. So maybe our near partners could give you more information on that, because it's a controlled environment, it's inoculated plants, and we do know for the in-lab measurements, we do know that these plants have no nutrients deficiencies. They only inoculated by yellow rust. So we have this database, we have our library that I've shown in the first graph from the in-lab measurements. From the in-field imagery, they have specific plots that are inoculated with yellow rust, brown rust, and septoria. And they are scored for every single campaign that we have done. There were 2 in total numbers, and they are scored both for yellow rust, brown, septoria, and nutrients deficiency. And we have as a control environment the plants that are off these specific plots, but they are divided by rice to prevent the spread of the diseases around. So we do have the scores. The project aim to specifically target at yellow rust, but we have included also brown rust and septoria. Although septoria can be seen from the aerial imagery because it's close to the stem, so we can't pick that signal. But I have developed the classification algorithm not to target only yellow rust, but to be able to identify different behaviors from the plants, from the neighboring plants. So if you know at the early stages that you have your plants growing, they should be healthy. You're flying your drone or your you drive your moving platform into the field, and you're picking some signals that are different from what is around, then you're alerted that something is wrong. The yellow rust is our primary target because it's further to the leaf edge, so we can pick up that information from our aerial imagery. But that doesn't mean that we are only targeting at this specific disease. I hope that answers your question.
If not, then you can discuss this during the lunchtime, but I would request all the questions to be short and the answers to please, because we just have about 5 minutes now before we move on to the
presentation, so I could have a bit longer. Sorry for taking up too much.
Thank you. My questions to Dr. Evans. Exciting stuff in terms of urban proposition for farming. I wonder whether you looked at the futuristic challenges that might bring in terms of the care of the diseases if we were to go that line. But the second issue is also, I know I've lived in England for some time, there is need to get land to build. What is the social, emotional contracts that satellite work have identified these places? Don't we put more buildings than farms? If you consider that, thank you.
Yeah, and that's a really interesting question. Due to the duration of the project only being a year, we were only able to collect spatial and environmental data, but we realized that these spaces, these vacant sites, were in some ways on the doorsteps of the local community. So one of the first things we did after the project, and this was pretty much self-funded, was hold a community open day, where we brought the residents out and asked, well, look, this is our dashboard, and this dashboard has suggested that this site would be great for seedling development, and this site would be great for food exchange, and this one would be great for food cultivation. What do you think about it? And on our dashboard, we've actually now integrated an option where users can tweak the importance of certain criteria. So for instance, if a particular resident really wanted to grow a certain type of crop because it, reminds them of their childhood, for instance, which actually is quite a formidable motivation in this community. Then if that crop required a certain sunlight or certain pH or whatever, then they can use this dashboard, tweak around the importance of the data criteria, and the dashboard will recalculate the optimization. So yes, listening to the community is so important.
Okay, I've also got a question for Daniel. You're working at the level of a London borough, and you've made the point very clearly that some areas are good for something, some is better for something else. Is the size of a borough the appropriate size that you are going to get everything that you need?
Yeah,
probabilistic.
Yes, indeed. I mean, also to kind of preface my last point as well, the fact is that we wanted to work in a community with an existing food growing community, and at this stage of it being a proof of concept project, we also wanted it to be reasonably contained. So that's why we worked at the ward scale, not even at the borough scale. But now, based on this proof of concept project, based on the fact that we've done this quite constrained, spatially constrained project at the ward scale, Islington Council are very happy for us now to move on to the borough scale. And indeed, actually, in the last few days, we've had talks with 3 other boroughs to create a kind of cross-axial transect. So we're able to now work beyond the borough, but scalability of this is going to be really important to do, and automating some of that data collection, processing, and some of that optimization is really important. And that's where STFC really comes into the room and has a big part to play.
Yeah, my question is to Lilik about urban farming. Did you consider in Indonesia? I think it's you, yeah.
Sorry.
Yeah. So, did you consider any, like when you identify the both livelihood stocks and also plant productions, any transportation logics and neighborhood supply networks? Or what was the logic initially? Did you consider just the availability of the productions and then looking for the demands? Is there any studies or future projections towards that direction? Thank you.
Yeah, thank you. At the beginning, we identified the kind of products, and then also asking how the products flow, like for the own consumption and also for the selling to the neighbor. And then we found that there will be some specific way of transporting the product and also processing maybe in the future. So if that is the case, then we can, expand our study with that the topic in the future.
I had this question with about the digital twin. I wanted to know what kind of real-time data is being captured and how that is it like hosted in the local server, and how does it get transferred? So if you can elaborate upon that, thank you.
Yeah, thanks for the question. So the digital twin, which we did and which I showed you just now, those are just based on the process level data. And these data are directly coming from the industries. They are held locally in their local server. However, most of the data and the model that is based on is mostly hypothetical, but I will show you the next project in the next theme where we are actually capturing the real-time data using the sensors, which is being held in the local cloud in that company, but they're kind of sharing it with us for the mutual benefit.
To add more, actually this project started during the pandemic, and all the real-time camera work, the data collection actually supported not because you couldn't get from this will we go to the real-time process. Thank you.
Okay, we just thank all of the session speakers one more time.
And please, if there are any further questions, please feel free to grab any one of us during the lunch break, and we would be very happy to answer any questions or suggestions that you may have. Okay. Right, now moving on to our final session before our lunch. So 2 more talks and then we'll set you free for lunch. Right. So with that in mind, we now have our second keynote speaker, Professor Megan Povey. And she's a professor of food physics in School of Food Science and Nutrition at the University of Leeds. I'm very proud to have her today. She was the first person to hold university chair in food physics, being appointed in 2002. What a commendable achievement. Thanks, Megan, for that. And she has more than 50 years of experience of applying and using physics-related technologies and techniques for characterization of soft materials. So over to you, Megan, for inspiring us for new food ingredients, only a part of sustainable food manufacturing story. We look forward to your presentation. Over to you. Thank you.
Thank you, Professor Chowdhury, and thank you for inviting me here to present this topic, which is very close to my heart, and I think it's an important one for all our futures. I'm Professor, as Professor Chowdhury said, I'm Professor of Food Physics. I'm a physicist and a chartered engineer, and over the years, I've studied food manufacturing process systems and then sometimes reinvented them, invented new processing methods, new machinery. At the moment, my interests lie in new sensor systems. I'm working with Jiangsu University in Zhejiang. My colleague, Dr. Zhang, is here. We've been publishing for over 10 years to develop these economic sensor systems based on food ingredients. So we, for example, anthocyanins from beetroot to generate colorimetric sensors, which are very economic. And if they're going to be used in agri-food and in food manufacturing, we need economic and commercial systems. Anyway, that's not really what I'm talking about today. What I'm going to do is look at the history of new foods, or, in 15 minutes, right? So it's a long history in 15 minutes. But my message is going to be careful what you wish for. Let's have a look at the context, the food industry itself. It's by far the largest and socially significant manufacturing sector in the UK. Approximately 11,000 businesses employing 430,000 people, contributing 28 billion to the UK economy each year. The sector's diverse. This is very important to understand. It's not in any sense monolithic. It's diverse in terms of materials, processes, manufacturing systems, its workforce and supply chains. Approximately 98% of food businesses are small and medium enterprises. And typically in these enterprises, research and development is much more difficult to support. So one issue that we've identified is the need for scientific support for the industry as a whole, and how do you deliver that in practice? It's also important to understand that sustainability is absolutely crucial part of our challenge, because 26% of global emissions, carbon dioxide emissions, result from food production, and in the UK alone, food manufacturing emitted 9.3 megatons of carbon dioxide in 2019. And to meet the national targets, such as net zero and the Kyoto commitment, in addition to international commitments, such as the UN Sustainable Development Goals, food manufacturing requires radical change across all subsectors, accelerated by a greater understanding of materials, ingredients, products, and waste streams. It must drastically reduce its reliance on carbon fuels. And as Ian Noble has said, this is a big challenge. For example, in baking, it's very difficult to replace baking in gas ovens with electric ovens. They operate in completely different ways, and the results are different. So we've got a challenge, but what I'm going to concentrate on is just this idea of novel ingredients. What are novel ingredients a solution or part of the solution? Well, clearly they are potentially part of the problem. Sorry, part of the solution. Okay, yeah, a little bit of a slip there, but my story is a story of unintended consequences. And what I want to do is look, first of all, at a traditional ingredient. And flour milling has been with us since the 15th century. It's possibly the oldest manufacturing process. And if we just look at wheat flour, and then we look at one part of that process, so the actual mill itself, then you can mill with stone, or you can mill with metal mills. In a metal mill, the flour is partly cooked because of the heat that's generated in the milling process. Whereas in stone milling, then it's much cooler process. There's far less cooking. The result is, depending on the manufacturing process, you get a very different product. And if you look at the flow sheet here, you can see it's complex. It's very, very complex. And there are other things which don't appear on here. So, for example, a whole mill has to be fumigated from time to time because of the insect contamination, small mammals, and these whole complexity of manufacturing is very important to understand. So we have a complex manufacturing process, highly dependent on the nature of the raw material. And I think this is pretty typical of manufacturing in the UK, that these processes have kind of grown like Topsy. They haven't been designed initially, and now the raw materials are changing because of climate change, whether it's cocoa or anyway, I've got to just be conscious that I've only got 15 minutes. So, right, an old novel ingredient from the 19th century, hydrogenated fat. The traditional food, butter, was replaced by hydrogenated vegetable oils in fatty spreads. And when this happened, and I'm going to spend a little bit of time talking about this, because it's common sense, isn't it, to think that fat makes you fat. But if we look carefully at this data, this is the US survey of obesity from the NIANS, and it's now being extended to 2019. So these trends are continuing, and what we see here is the obesity rocketing, absolutely over 25% in 2000. In year 2000, and it's going even higher. At the same time, if we look at the saturated and unsaturated fat and protein intakes, they are pretty constant. What's going up are the carbohydrates and the energy intake. And it's the second law of thermodynamics. I would say that, wouldn't I, as a physicist? But it's, you know, if you take in more energy than you expend, it's stored. How's it stored? Mainly as fat. And these carbohydrates, I mean, and we'll move on now to another ingredient. Okay, I think I might have been better if I'd put these slides in a different order. So let's see if I can go straight on to high fructose corn syrup. This material is produced by enzymic hydrolysis of cornstarch. what's great about this from the manufacturer's point of view is that for each molecule of sucrose, you end up with 2 sugar molecules, fructose and glucose. And of course, these sugars go straight into the bloodstream. There isn't a digestion process as there is in the case of, say, proteins or complex carbohydrates. From the manufacturing point of view, this reduces manufacturing costs, but on the other hand, most of this is transformed into fat in the body. Now, hopefully I can now, yes, I managed it, go backwards. Right, so that's, I hope I'm not going through this too quickly, but a newish ingredient, fungal protein. This took years to develop, and Rank Hovis McDoodle, who initiated this project, spent a lot. It was a very expensive project. It required careful safety analysis because of the concerns about the nucleic acid from the fungal proteins. I certainly occasionally eat this product. It's a successful product with a well-established market. But if you look at the actual ingredients, it contains egg albumin. It contains binders and may contain wheat, vegetable oil, milk proteins, barley, malt extract, and salt. Why are these ingredients in there? To make it attractive to eat, to make it enjoyable. That's why they're there. But on the other hand, you can see that this is a rather complex combination of ingredients. So I now want to emphasize the importance of a systems approach to understanding this. And I want to emphasize as well the essential, how consumer acceptance is essential. Systems approaches utilize concepts such as energy flow, whole life cycle analysis, whole system analysis, and consider research impacts on key issues such as consumer acceptance, health supply chains, manufacturing human factors, manufacturing costs, and skills barriers. And I've got a fly on the screen. Sorry about that. An integrated approach estimates the net effect of innovative technologies and activities on carbon emissions, nutrition, safety, and regulations, as well as consider how changes to greener fuels can be realized within food manufacturing. And in my view, and I know I'm not the only one here who has this view, it is essential to adopt this process if we're going to bring about a sustainable food manufacturing in the UK. And I think my aim, and for many of us, what we want to see is nutritious, enjoyable, sustainable, and affordable food for everybody in the UK. And in order to manage the change for sustainability, my take home is new ingredients are just one element in a complex problem. It's also important to realize that new food ingredients can bring waste along with them. I mean, and I think this last 2 days, I mean, with that, we were talking, I think, about, I've just lost that one, so I'll quickly move on to not make it another point, but you have to deal with the waste problem. New foods don't get rid of the waste problem. Any change is challenging for food manufacturers, and it's also important to know that the sector is dominated by legacy infrastructure, equipment and systems, all lacking flexibility and resilience. Even the buildings, Victorian buildings, you know, the flour mills were built in the last century, for example. And so you can't just say, oh, we're going to reconceive this whole thing from scratch. You can't. We've got to work with what we've got. So what we have to do is, first of all, have a good understanding of foods as materials, from the ingredients and the processed ingredients through the manufacturing process to the final product. But I think we have to look at all the people, all the processes as part of the future solution. And then we need to engage everybody that is involved to thinking about how we're going to achieve this sustainable future, which we must have. And
thank you, Megan. Thank you for letting us know that we have to continue our job with our existing factories, which are here since last 100 years, and we have to do something about it. So we will be hearing a little bit more on the legacy factories that we have and what can be done in our next session. But moving on to the final presentation, final keynote. Thank you, Ramu, for being here. So I present to you Dr. Ramajanelu GV from India. He is Executive Director for Center for Sustainable Agriculture. And unfortunately, he couldn't be here because on his way to the airport in India, in Hyderabad, he met with an accident. But how committed he is to be part of this conference, that he is wanting to do this keynote despite being in pain. So thank you, Ramu. I mean, such a level of commitment from you. He's working with more than now, in his bio there, it is written 50,000 farmers, but I know that he is now working with more than 100,000 farmers. And he would have been a civil servant today, but he left the civil service job to take up director role of NGOs who are working on ground with farmers, farming communities, and doing amazingly innovative works and also advising quite a lot to policies in India. So really looking up to your talk, Ramu. Over to you. Thank you for being here.
Thanks, Sunil. Thanks for this lovely introduction. This presentation, I'll try to restrict to talking about how shifting towards agroecology in developing countries can help to reach net zero, and particularly looking from the UK food industry. And this is a small project. We are trying to look at how the bilateral trade potential of agri-food between India and UK can be exploited, particularly looking from an organic markets, and design systems which can help to make this trade better. And just to put it in context, agricultural exports from India is around $434 million to UK, and in which rice and cotton becomes one of the major component. Nearly 50% of it is rice and wheat, rice and cotton, and rice and cotton are considered to be the dirtiest crops back home in India. So when we talk about food and agricultural trade, key important issue we need to look at is, unless we clean up the production systems, expecting that rest of the supply chain can make it more sustainable is not going to work. So more focus we need to look at the production level, and if the production level systems can be cleaned up, rest of the supply chain can be increased. UK is an important partner for India for organic trade as well. And again, cotton and rice are the major ingredients in the whole process, even in the organic ingredients. But what we need to look at from these two commodities is the ecological footprint of rice is nearly 10 tons of carbon equivalents per acre per year, per season actually. Rice is grown 2 seasons, so it's about 10 tons per carbon equivalent per acre per season, and cotton is around 4 tons per acre. And what this impact is, that the impact of this ecological footprint is not just on the farmers, but it is on the environment as a whole over there. So what can be done is either we need to shift in commodities, say, for example, in some of the processed foods, we can replace rice with millets. So the whole footprints can come down. Second is also shift in practices, probably shifting from conventionally produced products to organic products. I think that's a shift one can look at. So we try to look at what possibilities exist and then what are the benefits of shifting towards organic and natural farming compared to the conventional agriculture. So we took up around 9 parameters and then we try to look at whether it is about fertilizer use, water use, crop residue management, and also about how crop residues are incorporated and carbon stocks are built into the soil. So overall, shift from conventional agriculture to organic agriculture can reduce nearly about 42% of the emissions in paddy rice, and about 23% in wheat, 41% in groundnut, 40% in tomato, and in cotton, nearly about 50%. So we looked at different crops. So if the exports can shift from conventional to the same commodities, if we can shift from conventional products to organic, there could be a significant reduction in the emissions which are coming from the production system. Similarly, if we can replace one product with the other product, also the significant shift can happen. Say rice and wheat, rice can be replaced with wheat, or rice can be replaced with millets. So that can also further reduce the emissions. So in trade, how we can make these transitions between commodities or the way it is produced is something which is very, very important. And in India, organic scenario is increasing. So the area under organic is increasing significantly, and it is growing nearly by about 28% annually. And there is a projection in the next 4 to 5 years, the area could be doubled. So the transition towards agroecology is happening in the country. But that's not sufficient. We are into a context where the policy measures at the national and international levels are changing. And the changes in the standards and the compliance systems are leading to new trade barriers. And these new trade barriers are limiting the exports, and significantly the organic exports from India in the last 2 to 3 years has come down. This is because of the way the policy changes happened. And the biggest change happened this year. So from December 2023 onwards, EU organic certification system is moving from an equivalence system to compliance system. And that requires 3 years compliance, and agencies which are certified by UK need to verify. So all this is going to further impact on the organic exports from India to UK. On the top of that, there are several labels, private labels, and this multiplicity of labels and claims are creating complex situation. And there is also data trust issues, and how do we manage the data, and then how the data, the trust between different parties can be established is also very, very important. And just to give you a couple of examples and couple of key things which has happened. In 2003, there was a initiation to create equivalence among organic certification systems across the world. And all that ended last year, US moving out of it. And this year, EU is also moving out of it. If both the major players are moving out, now every country has to manage its own data, and each country has different compliance system, and it's going to complicate the entire organic food business in the next few years. And like I mentioned, the private labels, so many labels. And we recently, when we are trying to do a study, at least there are 16 labels a retailer has to put it onto the packet, in which at least 6 becomes mandatory if you want to send agricultural products, food products in the market. And each of these certificates is offered by different agencies and different data management systems. So the cost and then the burden on the people increases. So that's another major issue which one need to look into if you want to increase the shift towards more sustainable production and consumption systems. So coming back to the organic farming and the net zero, I think organic and natural farming is a great potential for mitigation in terms of reducing water use, energy use, and chemical fertilizer use, and also in terms of organic carbon sequestration, soils, in soils or trees. And there's also a lot of social good which is done because the share of consumers can be increased if the farmers are also collectivized there and can be linked to the markets. So what we propose to do and then what we are trying to do is to build data stacking where all the data management systems can be brought together, and in the single database we can manage organic certification, traceability, and also the ecosystem services. Very fortunately, in the last 10-15 days, Government of India has come up with new very important programs. One is called PM Prana. In this, Government of India is talking about any state which is reducing its fertilizer use, 50% of the fertilizer would be, that subsidy would be transferred to the state, and state can use it for promoting agroecological approaches, and it can be also be transferred to the farmers who are actually practicing it. But there's no mechanism of tracking which farmer has reduced how much kind of. And similarly, the green credit systems has been brought in, where reducing in water use, energy use also can be quantified and it can be traded in the market. These two are the new initiatives Government of India has already began. And carbon sequestration is already in the market, where the voluntary markets are offering the carbon sequestration as a potential. So these ecosystem services can also be managed if the same data can be used. So if we can have a data stack where from the production level support to business planning to quality assurance to traceability to ecosystem services can be built into the same system and build trust between players, I think this can be the great potential in terms of ensuring the quality. Similarly, farmer producer organizations are becoming a major source of platform for procurement. Today, India has 33,711 farmer producer organizations registered, and the number is increasing day by day. And they are registered as companies, they're registered as cooperatives, and some are registered as a mutually aided cooperatives, women self-help groups. So there are many formats for all these things. And the farmer producer organizations become very important in Indian context because 85% of Indian farmers are small and marginal who own less than 1 hectare of land. So the last mile delivery of support services and the first mile aggregation of products is a major challenge. And these FPOs can become the major platform for collectivizing these things. So what we are trying to do is to help farmers to transit towards sustainable production systems by providing extension and advisory services and business development support. And today at Center for Sustainable Agriculture, we work with about 63 farmer producer organizations, which has about 50,000 members registered. And we also support another 232 FPOs as a resource organization. So with all of them, we are trying to put all these data management systems in place. So with the help of Sonal, we are also trying to build a data stack. We call it as e-Krishi, which helps from production level to institutional level to data quality assurance level. So all this data can be managed easily. And we are also trying to link to the markets and ecosystems, the farmers. And we are also trying to engage with the policymakers so that both field level transitions can happen and policy level transitions can happen. Recently, we organized a workshop in Hyderabad with Manage, which is a National Center for Agricultural Extension Management, and also a center of excellence for natural farming in the country. So Sonal was here and Raymond was here. So we had a good discussion with various stakeholders who are into the process of organic certification. So the farmer cooperatives are providing this set of services through farmer service centers. So on one side, it's the extension and advisory services, and the other side is the business development services. And together, we are seeing that farmers' productivities, cost of can be increased, cost of cultivation can be reduced, and the price realization can happen because of the collectivization and the transitions which are happening. And using the same data, we can look forward to link it to the markets.
Did we lose him? Okay. I think it was nearly coming to an end. Yeah. Yeah, okay.
Safe quality products, the last few minutes. So the progressive certification system, so moving from one certification system to another certification system should be easier. Currently, now all these equivalence is broken, so we need to have a better system over there. And verifiable quality standards, the private labels are bringing in many standards which are not even possible to verify. And so how do we create market acceptance for the consumers for net zero products is also something we need to collectively think about and engage consumers for this. And if these transitions have to happen at the in the developing countries at the farm level, we need to create an ecosystem which can help farmers to make the transition, create market systems which can help them to get into the market. And in the guidelines, the national guidelines can be similar and voluntary guidelines can be added to that rather than currently having different set of guidelines. Traceability is becoming very important. And certainly if consumer want to know what is the ecological footprints of the food they are consuming and what is the safety of the product, traceability is going to be an important issue. So building that into that stack will help, and put the same data for multiple use. And so data stacking is critical, and FPOs as units where we can work and source the products. So that's the transition which can help. Thank you. I stop here.
Thank you, Ramu. So yeah, thank you, Ramu, for that insightful talk. I hope that that has ignited different ideas in the audiences, and I am happy to fetch any questions during our lunch break. And I will feed it back to you, Ramu. I think Divya is also here. So myself and Divya, we will be fetching any questions related to this presentation that Ramu has kindly presented to us despite being in pain. Ramu, we wish you a speedy recovery, and we hope to see you soon in the UK. Yeah.
Thank you. Thank you.
Thank you for being part of it. So now, ladies and gentlemen, please, may I invite you to join the lunch, and please carry on networking. And if you have any questions related to any of the keynote or any of the presentations so far, please feel free to grab the speakers and have your conversations there. Thank you.
In the atrium on the ground floor.
Okay. The lunch is at the atrium on the ground floor.
We'll be back at 1:45.
We'll be back at 1:45 as Cindy instructed. Thank you, Cindy.
Yeah. Oh, okay. So we can start the yeah.
Thank you all.
COVID pandemic, I think quite be late. It just ended up with the more. So
And you just play the video and you don't see the difference. It's like you have a same thing that so that it's important. So yeah, so they don't need to actually address their physical yeah, you simply find out if I invest this, if I have how much time investing, what is the return on investment on the table, and you can actually calculate that. Exactly. You can calculate
So we will mark number 17 with 10.
That's going to become 10.
Yeah.
Yeah. Becomes 17. Lovely.
Awesome.
Done?
Yes.
What's happening immediately after lunch? Is there going to, are we straight back into the same format
Yeah, with
of
the
presentations?
presentations.
Okay, so I could load this one up now then, couldn't I? Do you want me to put that holding logo at the beginning again? I wonder if I still got it. No. Unfortunately. No, never mind.
तो बेसिकली उनके जो रियल टाइम जो IoT गैस I get the fact that you integrate between I need to double check this.
I'll let everybody else get stuff first and then I'll what's left. Yes, we'll do. Thank you.
And then we can work out
Yeah, well, I think that's I'm not just trying to make it links now, so it's nice to talk with
Today has left.
He's outside and speaking from here. Wondering, okay, so let me yeah. Yeah. Thank you. Yeah.
Thank you. Yeah, I mean, probably.
Yes, I thought like an application has been put out in the homework, but no one will call the cop is something like secret work done with the word. So I did a phone call that, so I can give you that out. Yeah, obviously they'll have something to work from prior to what I'm doing. Yeah, we can have a chat whenever. So do that. Okay, thank you. Yeah.
maybe in the conference level. Yeah, they kind of, they don't help me start, so I don't the same fast. It's like, well, the person who did it fast time is not at the university anymore, so you need to tell us what you're planning. What sort of you like. Yeah. So we'll kind of make it happen. Yeah, me and Craig doing it, so the schools will come on. But yeah, it's just not sort of something out again. So it's be nice to my idea be there sort of 3-4 o'clock in the afternoon so we can do change. We do about 5 o'clock, so we'll have that and then university information. You need to know what's going on in these two places. Well, hey, Mo. Yeah. It'll be fun. I think so. This is cool. The rain takes out like the to do a room and then we sort of I'll pop down shortly.
No.
shame that one of those. Yeah.
I will share. I will find it. Hello. Half minute per minute. हम audience में हैं, इनको खूब जरूरत पड़ेगी तो बताइए कौन सा। Schedule or you're going out? No comment.
So good afternoon, everyone. Welcome back from the lunch. I hope we are not too heavy to start the session. So, and we'll continue to have coffee to keep ourselves energetic and going. So, the first presentation would be from Mr. Sarang Ved, and who would be presenting about virtual marketplace for urban micro enterprises and small farmers growing fresh fruits, vegetables in India. And this project was funded by STFC Food Network before the pandemic. But before telling anything more, I can invite Sarang to have his presentation.
It's just a lecture, right here.
Do we have the next speaker?
Yeah, we'll go.
The Raymond is presenting back at like second last. This is the wrong slide. Okay.
So we'll moving over to the next presentation and we'll try to adjust. Our next presentation is by Dr. Manish Shukla from Durham University. So may I invite Dr. Manish Shukla? Oh, he's already, he'll be doing the virtual session. So over to you, Manish.
Thank you so much. Thank you so much for giving me this time. Just to reconfirm, how much time do I have to do this presentation?
So we have 5 minutes for each of the presentation
Okay.
allocated. So at 4 minutes, I will give you a polite reminder.
Okay, that's quite quick. No problem at all. So I'm just trying to share my slides. Are you able to see my slides, please?
Go full screen, please.
Yeah. Okay, guys. So, hi everyone. Are you able to see the slides?
Yes.
Yeah, excellent. So I'm ready to present whenever you say.
Yeah.
Okay, perfect. So we proposed this project about virtual inclusive farming clusters, especially looking at the global south, and with the idea to address the sustainability issues and digital divide in the global south. And one of the major concerns or one of the major problems that we saw was that there are millions of smallholder farmers who are involved in very small volumes of input and output, and that's why they are not able to be a part of the larger global supply chain. Now, there are a number of solutions that have been tried in the past in literature as well as by practitioners, and one of the solutions that kind of works is farmer producer cooperatives or cooperatives that are owned and run by the farmers. So this is one of the successful model, but with very less success. Now, why we did this project at this time is because Government of India has come up with a very ambitious mission where they decided that they will create a 10,000 new farmer producer organization. So they are also at the same time were thinking about aggregating the farmers. So we thought that, okay, this is a good time and this is very much aligned to what we wanted to do. Now, looking at the existing FPOs and also the new farmer producer organizations that were coming, we saw that, okay, the success rate, even though they were able to form a cooperative, an entity, but the success rate was very limited. And once the funding is gone, they were, they were returning back to what they were doing. So we started to look that what are the major reasons why this thing is happening. And some of the main problems that we identified is that there was a lack of a proper organizational structure, which is an equivalent of an organizational structure and processes and things like that in a company. Those things were missing in these farmer producer organizations. The second bigger issue was that there was lack of management skills. Most of the people running these cooperatives generally come from the farmers or the same families or nearby locations. So they were not well trained to run a company or a cooperative. We also found that a lot of these cooperatives were very highly influenced by few members or few families who had a lot of say in these things. And another big issue was the administrative cost of running the entire thing was too high, and these FPOs or cooperatives were not able to make enough money. And apart from these internal issues, we also found that there are some external issues supply chain wide. For example, most of these cooperatives were mostly production oriented, so they want to sell what they are producing rather than looking what the market needs. They had very limited access to the market, so very less market channels they were connected to. And they were not a sort of a brand, so they were still kind of competing at a price, at a product or a commodity level. So these were some of the major challenges. And we found that most of these cooperatives are kind of male dominated, where people can are able to participate and communicate, whereas elderly and women are kind of excluded by the sense that they cannot travel and attend meetings and participate and have their say in this thing.
One minute.
Yeah, okay. So with that, we propose this idea about creating virtual clusters. So rather than bringing them physically together and creating an entity, we thought that we will bring them virtually together and create this entity. And then we will create multiple entities on this entity. So from the farm level to village to block and district. And based on that, we did few things. I can go in detail in the questions. We did surveys, we talked with people, and we created this initial prototype. This is how the virtual farming cluster looks like. A lot of things you can do with this. We tested this thing with 5 farm cooperatives. After that, we went again to farm cooperatives and retailers. We tried to, approach a lot of them. Interviewed few of them, and around 51 of them said that okay, they are happy to trial this thing. So first round we had trialed with 5. Second round we are going to trial with another 51 of these. And in the next phase, we are looking at developing the next version of this prototype. We have 51 of the entities ready to trial this thing. And also we would like to measure the impact of the existing 5 users. And the next steps also involve that we are looking for more funding, or follow-up funding, maybe from STFC or Innovate UK Smart Grant is another thing that we are targeting. So yeah, thank you so much for listening to this presentation. And if you have any questions.
Thank you, Manish, for your presentation. And we are moving over to our next presentation by Mr. Sharon Vedder from GoFresh India.
Okay.
Manish, you will be taking questions at the last of the presentation, so be there to answer if there are any questions related to you.
Yeah, sure. Thank you. I will.
Thanks a lot. And I would also say sorry. So this is a project that we have been working with STFC for pretty long. We actually started this with during the COVID time, and then we have taken it forward. So just to confirm, this is on the virtual marketplace that what we are trying to build in India. And the focus is the fresh fruits and vegetable supply chain. And so we have Dr. Yen and Dr. Tom from a STFC side, Coas, Raymond, Saeed, as well as Rakesh had supported us on doing a huge amount of, I would say, a validation verification of this particular model. And so I'll just go ahead on this. Yeah, so what's important as far as India is concerned, and also I would say the agri supply chain is concerned, and I'm talking here about the post-production one. So it's basically from the farm to the markets and to the especially I'm saying the B2B marketplaces is that what the focus is. And it's lack of access to market is really the most important issue all over. That's what we had seen. There's also a lack of information, which also creates a lot of issue. And we had also seen there's one more, which is lack of finance. So these are the 3 which are the primary ones. But our scope of the project, we actually focus on the lack of access to market as well as information, how it need to be done. So what we had actually seen is that there had been a difference pre-COVID and a post-COVID. As far as India is concerned, there has been, I would say, because of digitization and also the regulatory support which has come into picture, and more importantly, also, I would say the consumer behavior which actually got changed post-COVID. So it actually has, I would say, accelerated the digitization all across the different levels. So what we are actually trying to build here is a resilient supply chain, which actually wherein we can connect the marginal communities on both the sides of the spectrum. So on one side, we have small farmers, and on the other side, in a B2B supply chain, we have the retailers, or it could be small kitchens and all. And essentially, so this had been the approach. We actually defined and refined the project. Then we actually went into a methodology on the research methodology. There were key hypotheses that what we have agreed on, and then we actually checked those key hypotheses when we did an actual pilot on the ground. And based on that, what was typically done in this particular project is that not just keep it to the lab, but do an actual project on the ground. So that has been a difference, and I would say huge amount of support. We also had another team of experts in India and in STFC. So it was a joint project which was taken up. And we are also at a stage where we actually did a commercial launch of this. A month back, we actually rolled it out on ground. So that's the, I would say, a support which actually STFC has provided at the initial level, but it actually is a running project. And hence, I would say that all the researchers as well as the experts who are there online as well as in this particular room certainly will have an access to whole of this particular observations and the data as well as the insights that what we get. So I will go with the academic research as well as the on-field project as well as the commercial launch. So it actually started with, various different findings, but when we actually gone on the ground, so the things change a lot, and we are actually right now rolled out with a, I would say, aggregator to a micro retailer is what the focus is. And we are going ahead with this particular project into two different, I would say, phases. So the first phase is something like we started actually with connecting farmers, small farmers first, but then we realized it's important for us to have a demand-driven approach. And hence we are looking at now, we started from the downstream. So we are connecting retailers, the small retailers first, having that captive demand available, and then basically would go in the second phase with the farmers. So that's what basically a change in approach, and also after getting the actual feedback on the ground level. So here what we are looking forward in this particular financial year, we would typically touch base around 8,000 plus retailers who would be completely digitized on the platform. And yeah, so we are doing this small project right now in Mumbai only, and the focus is fruit. So we are not doing everything. We have actually limited ourselves on getting it rolled out and having an efficacy of the system tested every now and then. So that's a difference. Yeah, so we are typically looking forward for a, I would say, support from the ecosystem. The support from ecosystem is certainly typically on the data integration part, because that's what is going to be very, very important. Data analysis and also of fund and grant support, I would say, even through an equity as well as through a grant support is what we look forward. So that's what the background is, and I look forward for everyone to support on the project, and also see whatever the learnings are there can be applied not only just in India, but all everywhere. Thanks a lot.
Thank you, sir, for your presentation. And the next presentation is from the Expert Working Group Digital Platforms. So Anurag, Dr. Anurag Tiwari is going to present.
Well, good afternoon, everyone. Have they located it? Number 12, this one. It's a complete dozen. Yeah. Okay. Good afternoon, everyone. Our expert working group looked at digital platforms. We were interested to find how apps and websites are doing in terms of small stakeholders, and it's a very right presentation to come after a presentation of the platform that is actively working. What we were interested in was that what are the kind of services that these platforms are providing, and what are the kind of services that the farmers are looking for? Is there a right kind of mix, or is a right kind of connect between what they are providing and what they are looking for? Because not every platform is a hit. There are so many platforms that have come up, and there are so many platforms that have closed down. We just asked a simple question to ChatGPT: how many digital platforms exist out there? And ChatGPT returned us close to 100 names, and most of them were inactive. So there's something happening in this space. A lot of people do come in, but still they are not able to sustain. And this is what way we would like to see what's happening there. So this was supported by Dr. Mojapa from South Africa. Jens was supporting Arena and Dr. Joseph Arya. Yeah. Oh. Yeah, okay, a bit of delay. If you look at the kind of services that that farmers require, they have been doing these kind of activities for many, many years, like land advisory. Means every farmer knows what kind of crop grows at what time, at what kind of land. They have crop advisory, local knowledge is there, a lot of local knowledge is there about what to add, how to fertilize, what kind of time for irrigation and so on. However, there's a bit of a difference from what previously the models used to work, because they were not dynamic. In a nature, in a way the world is progressing now, everything is very, very dynamic. Farmers might have a knowledge, but they might not be able to relate it to the real-time changes. And this is where our food challenge comes into play. How can we digitalize all these aspects and present in a user-friendly UI? And how to make it widely available so that it is adopted, it doesn't die out, and the right kind of services are being used by the farmers. With this ideology, we conducted a pilot study. We went into the digital platforms as experts, and we interacted with these platforms and tried to understand what these platforms provide, how they provide it, what are the kind of data sources that they use. And with that objective, we laid down 4 objectives for our working group. That was to develop a framework to capture these platforms, how they are doing here. Identify the stakeholders associated, identify the technologies associated, identify the data sources and data analysis methods that they are using. What are the extract, transform, and load kind of capacities that they are presenting in the platforms. So in this pilot study, we created a survey instrument. We tested it. We had multiple revisions of it. And then we went on to collect a pilot of 15 data platforms where we were able to capture some aspects of their operations. The preliminary results show that there is a lot of things happening, but there are some overlaps in terms of what things are working, what people are doing, what they are not doing. So descriptive, the platforms that we studied were all across the globe. This is kind of a representation of globe. It was across the world. They have been active, so the maturity level was pretty high. Most of the platforms are active for 5 to 7 years or more. And it's the cumulative people that it had served was in the range of 3.55 million. Yeah. But if you look at the services that these platforms are providing, this will let you know that most of them are into e-marketplace, which a biggest rectangle shows you that that is most of them did. And a very few have been in spaces like the smart buying of seeds, agri inputs, and renting equipments and so on. So we got an idea of the landscape, how things are working in this area. We looked at other aspects also, that how are they interacting with the users? What are the kind of technologies that they're using, whether it is a OTP-based interaction, whether it is a email-based interaction, or are they responding on call centers or phone or over a phone or something. We also looked at what are the data sources that they are using. So preliminary studies again show that most of the time these platforms were using, if they are providing any kind of advisory, they were using user-generated data. So most of the time they had a platform where people could come together and talk about what are the things. The next steps for us is to conduct a full-scale study, because we did just a pilot data collection. And for the next steps, we'd like to conduct a full-scale study and understand how these digital platforms work. We might be interested in calling them and presenting to us that what are their challenges and what are the things that they would see as a future area of growth. Well, thank you very much.
Thank you, Anurag, for such a wonderful presentation. Our next presenter will be presenting remotely, and the topic is IoT-enabled cold chain for Kenya and Uganda fish market by Dr. Ahmed from SFN University, UK.
Hi everyone, so I'm trying to share my slides. If you give me a second, please. I hope everyone can see my screen.
Yes.
Right, okay, thank you. Actually, I'm presenting today on behalf of the team of this project. And this project is IoT-enabled cold chain in fishery sector. And the geographical location of our project is Kenya and Uganda. So our collaborators are Kenya Marine and Fisheries Research Institute and RAD from Uganda and Aston University, where I'm from. Actually, the challenges in East Africa is there is a huge waste actually of food, including fish. And this is primarily because of lack of cold chain. And the impact we try to generate actually is to address this challenge. There is a lot of people working in fishery sectors that they can't make proper money because they can't deliver actually fish in a good quality at time. And simply it is wasted. Fish in East Africa constitute a large portion of the human protein intake. So it is important actually to save this amount of fish. And this little clip actually by our collaborator from RAD showing actually how the fish is transported in Uganda. So if we look at the cold chain actually, so after harvesting the fish, there is obviously try to transport it for processing or selling to the market. So we can go straight away to the market as a raw fish, or we can process it after harvest for better marketing or adding value for the fish. However, when we do surveys actually and asking people about their access to cooling, only 10% can cool food stuff in Africa. So 90% don't have access to cooling, either storing or transportation, refrigerant transportation. There is a lot of proposition actually to store the food, but the link which is transporting the cold food stuff is still missing. And that's what we try to address in this project. So what we're gonna do actually, we're doing applied research to develop a cold box, and this cold box can transport the fish from one location to another. And this cold box is fitted with IoT sensor, and this sensor can sense the temperature of the cold box to ensure that the fish is transported at the right temperature, and can actually track the GPS location of the cold box for better logistics. So in future, if we want to connect this cold box with a wider supply chain, so we can connect it using this IoT sensor. And what we'll try to do is we'll fit a cooling battery inside this box, and this battery actually can store the cooling energy for enough for transporting the fish from one location to another. This was a CAD modeling for the cold box itself. And as you can see, there's a box body, and there are 4 thermal energy storage units, or coolth battery, because it stores the low temperature energy. And they are modular, swappable. They can be charged or freezed at one location and another. So if we have
1 minute left.
100 of those boxes, actually, we can replace these batteries at any point. What we did, actually, we developed this here at Aston University. So this shiny box is a cooling battery. And this actually is a demonstrator for the cold box made of wood. And we sent the design to Kenya. So they made it out of metal, and they tried out in Kenya. And this actually, the IoT unit connected to the box, and showing here actually it can track the location and temperature. And this actually is a lab testing for the charging and discharging of the cold box while it's transport about 5 kg of fish from one location to another. So yeah, this is actually in brief our project. I hope I didn't exceed the 5 minutes window.
You're exactly bang on time.
All right, okay. Yeah, yeah, I'm happy to answer any question if you want.
So please be online. At the end of the presentations, all the presentations will be asking questions.
Sure, thank you.
So thank you, Dr. Ahmed, for this wonderful presentation. Our next presenter is Dr. Brian Shanishi from Science and Technology Facilities Council, and he will be presenting on portable food storage in India. And I was fortunate to be a part of that project working with him on this.
Great. Thanks, Rakesh. So I'm Brian Shaughnessy. I work for Rouse Space. I'm part of STFC. There's a little red light on it. So my day job is designing thermal systems on space science instruments. What I'm interested in is how I can take some of those ideas, the work I do, the insulation, etc., that we produce for spacecraft, and to see how we can apply that to food challenges. So in a way, I'm kind of presenting what I know and then hoping that other people can see an opportunity there to talk to me about. On this project, this is specifically looking at portable cold food storage. I worked with Sarang, who was providing all that local knowledge out in India, and also with my colleague Livraj, who did the analysis for this project. So I just skip through this quick. India is warm. It is difficult to keep fruit and vegetables cold. If the fruit and vegetables get warmer, they potentially get wasted, and that's what we're trying to prevent. So we're exploring ideas to improve that. We used our thermal expertise, our software and knowledge of spacecraft instrumentation to look at opportunities for improving the thermal design of portable cold storage systems. And this is looking for things like retrofit options that we can put onto containers, crates, or even indeed changes to crates themselves to make them better performing. We developed a very simple thermal model, not intended to be a model of how a tomato really behaves in a real crate, but to give us an idea of what happens when you try different things to control the thermal environment of the tomato in the crate. So here we have the diagram of the very simple thermal model that we did. I mean, it's showing a number of tomatoes in there. We didn't represent each of those tomatoes. We represented it as a lump, a single node representing all of those tomatoes, a single node, thermal node representing those the crate. And we looked at the heat inputs and heat outputs out of it. Got charts rather like this one on the right-hand side. Within the scope of this talk, we can't go through all the detail of this, but we were looking at what happens if you make different changes to things like the thermal efficiency of the insulation or the surface properties of the crate or whatever's around the crate, and seeing how that affects the temperature response over the course of some days. Came up with a number of possible retrofit options that we could investigate, and that's what we'd like to move on to, working with other people. So things like taking spacecraft multi-layer insulation, like the photograph on the right, adapting that for terrestrial applications, and looking at thermal finishes, selective thermal finishes like the diagram on the right, which reflects sunlight, but also radiates a lot of heat, so it can have a cooling-like effect. So we produced quite a comprehensive report, so all of the detail is in there. So if you want to find out more, that is where to look. We identified a few options that can be pursued. What we want to do is to try and be able to pursue those. So we want to meet people that can help us provide them some insulation, put some insulation on a crate or some produce, put it in a field in India or wherever, and see what happens. That's what we really want to do. There are other opportunities as well. Refining thermal modeling. One final thing I want to do is, I mean, this is taking knowledge from space, applying it to food problem. If I learn stuff doing this, I can take it back in space world. And I'm hoping that I can do that and improve the insulation that we're using in spacecraft as well.
Thank you. Finish with 22 seconds before time.
Wow.
So thank you for this wonderful presentation again. And the next presentation is from our expert working group, Cold Food Chains, and we'll play a video.
Hi everybody. I've kept Brian up here because he was part of this group, and he's just going to go through some of the outputs that he did. Thank you. So let me just start by going through the slides. Are we in? Sorry, I've taken control, haven't I? Terrible thing to do. Okay, I'll let you do that. Thank you. So, as you've already seen, food loss and waste is a huge problem, and it's been great to come at this part of the session because you've already seen some of the issues, and we know that we really desperately need to reduce food loss, but it's a complex problem. And one of the big challenges, of course, is the cold chain. So that's what our group has come together to look at, some of the challenges and opportunities that exist in this space. So if we go to the next slide. Okay, I'm not going to break it this time. Great. So Brian, over to you for your output.
If that's the wrong slide set.
The same slide has been taken. No.
Oh yeah, so
it was the slide Brian was using earlier.
So yeah, whilst they're sorting that out, I think the cold chain is a very complex problem. And actually, when you talk to people in the industry, when you talk to academics, you quickly realize that there's so many angles and aspects to this that needs to be resolved. And I love the fact that we're bringing in space technology to try and solve some of these issues. So Brian, of course, has been involved in the prior project, but as part of our team, he was able to look at some of the materials that are used in the space industry and see how that can be utilized potentially in the cold chain. So I think we're about ready to go. Yes. Are we there?
I think we found the right presentation. Not this one. Yeah, this one. This one.
Oh, that's
Number 15.
right. Yeah, there we go. Fantastic. So yeah, been through this. So we wanted to do 3 outputs. The one Brian's going to talk about. I'll talk about the other one, and then we'll finish off with a video, which is 3.5 minutes. So, Brian.
So that must mean I have minus minutes now. We already seen that effective insulation and thermal isolation is crucial for advancing cold storage solutions. Suitable insulation is not always available. In some countries it is, some countries it isn't. Even if it is available, it might not be used. There are also environmental concerns with some materials, so polystyrene, for example. I did a review, very top level, quick review of some literature looking at developments that might have a positive impact. Came up with some ideas around alternative insulation materials, for example, crop byproducts or biofilms, stuff made out of seaweed. And also, as I mentioned in the previous talk, adaptions of spacecraft insulation. I did a summary document to raise awareness of these things and to highlight some opportunities for further development. Suggested an action plan, evaluate use cases of cold storage in developing nations, focused literature review on novel insulation systems, but crucially, actually making something and testing it, getting to a point where we're not doing too much research and we're getting to a point of actually trying these things out and seeing if they work. Thanks.
And I love that aspect because I'm maybe a doctor, but actually I consider myself more of a fish farmer because that is my background. I've run a fish farm in Uganda, and that's why I'm interested in coming to this, because there's some great ideas, but let's get them into action. So the second output that we looked at, actually Sarang, who presented earlier, went and had a look at the Indian seafood, and we because there are so many complex issues around the cold chain, we're trying to narrow in on specific things that we can look at. So he presented a document where he's looking very much at the Indian seafood industry and some of the challenges and opportunities that exist there. And I'm pleased to announce that he's actually considering putting seafood into their platform because he sees the benefits of connecting suppliers directly to market, which is I was thrilled to hear that. And then the last one is just the video that we've put together. And really, this is a top level look, and it's designed to give you sort of a way in to understanding this problem, and specifically, I guess, honing on fish. So we could play the video. Next slide.
Around a third of food produced globally ends up as waste. And in a developing context, this can be due to a lack of a cold chain solution. Produce such as vegetables, fruit, dairy products, meat, and other items can rapidly spoil and be wasted if they are not processed and stored properly. A functional cold chain is a vital step in ensuring that the food we produce globally is consumed and doesn't get wasted. STFC has been tackling cold chain issues in a developing context since 2018. This includes funding 4 scoping projects exploring opportunities within cold chain technologies. Let's focus on a specific cold chain issue, fish, to highlight some of these problems in greater detail. With wild capture fisheries at capacity, the aquaculture industry has rapidly increased to meet the demand for fish as a high-quality animal protein. Much of this growth is now centered around developing nations and their ability to supply fresh fish to their local and international markets. Fish is a highly perishable item, and appropriate cold chain solutions are essential to meet the supply chain challenges. In many parts of the world, fish is supplied without a cold chain, or fish reaches the cold chain after some time. This has an impact on the quality of food, the safety of food, and leads to food waste and income loss. Technologies that extend the shelf life of fresh fish have enormous potential to not only reduce fish waste, but also improve incomes for typically poorer farmers and fishers in developing countries. Even when cold chain solutions exist, current solutions, i.e. polystyrene, are very wasteful products and difficult to dispose of. Fishers and farmers are also facing challenges due to climate change. Changing weather patterns are affecting wild fish populations and causing extreme and unpredictable weather events. Land use change also increases the risk to fish farmers. To overcome these problems, STFC is using their expertise to tackle on-the-ground problems faced by farmers and fishers in developing contexts. One innovation in Kenya and Uganda is developing a prototype that will enable those selling fresh fish to chill their product and monitor the conditions while the fish is being transported to market. With an estimated 56% of fish being lost post-harvest due to a lack of cold chain, an intervention is desperately needed. The project will develop a smart cooling container equipped with Coolif batteries and using IoT sensing technology to monitor the fish supply chain in real time. While there are many challenges along the food production chain in developing countries affecting aquaculture producers, STFC is combining their expertise to tackle these real-life problems and bring benefits to many along the food supply chain.
Thank you very much.
Thank you, Brian and team, for your presentation and this wonderful video. So, our next presentation is from the Expert Working Group Bioeconomy and Food Systems, and the whole group is going to present.
Hello, and thank you so much for staying on, and really pleased to be here. On behalf of the Bioeconomy and Smart Food Systems for Sustainable and Healthy Futures, I welcome to you this presentation. My thanks go also to Sonal and the STFC funding. Also grateful to the output leads. So we got Professor Steve Houston with us and Dr. Elton Smith in the audience. I'm sure some of our output leads are also online. So thank you very much for attending, and to our group members who help us with shaping this expert working group. So basically, the food challenge that we tried to address was bioeconomy, and how can we use that to address the systemic sort of problem that we face, obviously, with the climate change emergency, the trends of the sort of warming of the planet, and the different types of action that we can take. But how can technology help us to address those issues in the context of the bioeconomy? So bioeconomy is defined as those biological products that are in existence in the land and sea, in the natural environment, but then how can we reuse them or use them in a way of creating new products, systems, and services? So why is important and why now? So basically, we need to transition to a nature-based economy rather than continuing with a fossil fuel-based economy currently, as we know. We need to make efforts from different angles, and I think the bioeconomy theme provided that a systemic sort of context, and to see how different inputs and transformations help hopefully to reach those outcomes. Finally, we would like to have, that decarbonized future and, first of all, sustainable future for the generations to come after us. What methodology and approach we carried out was basically divided into three outputs. So the first one was with interviews with experts and some principal investigators from previously funded projects by the STFC. We're thankful for those people who provided their time to our colleagues who are leading the outputs. Second output was on positioning papers, which is currently being drafted on the key insights on the drivers, trends, and the future research agenda. And that's Professor Steve Houston leading on that. And then we had this output 3, which was basically on a web online panel discussion. So we didn't want to call it a webinar, but it was a panel discussion, which consisted of 4 experts. So we had 2 of our members, so Parag, who is also here, and Dele, who is from Finland. He actually also participated in that. And we had Lucy Hopwood and Duncan Williamson, if I remember rightly. It was quite a well-attended event. We're thankful to Sonal as well for being there to give the overview of the panel discussion. So the idea was to develop that sort of provocative arguments on how can we actually use bioeconomy opportunities to generate that transformation of the systems that we currently, food systems that we currently have. So some results, key results and impacts. So we basically came up with there is a need for a systemic approach, and especially stakeholder collaboration. I think we agree that we need a multidisciplinary and multi-stakeholder approach to the problem. And funding needs to be directed to this type of, sort of different areas that are less explored. In particular, I think we identified the different possibilities. For example, there was the value from waste. There was one of them, biorefinery of different products, and also different ways of how can we transform our food systems into healthy systems, right? So the food for health connection as well was identified. And hopefully this will help towards a national bioeconomy strategy, taking into account those food systems, but also how is the intersection between the different non-food systems with the food systems as well. So that will bring in even more transdisciplinary and multi-stakeholder approach collaboration. So how do we plan to take this forward? So we would like to disseminate the summary of our results using online platforms, and Dr. Elta is going to prepare or help us with that. We'll try to follow up with the proposal drafting of some key potential applications. I believe there's some calls on the way coming perhaps for us to tackle. And then we'll report on these challenges and opportunities, as well as barriers and enablers for this transition. And hopefully we'll still be able to organize a one-day multidisciplinary workshop to continue the conversation that we initiated. I must say that this was funded mid-March. So yes, we formed 4 months and a bit of research, but it's been a brilliant collaboration, really thankful for the opportunity to collaborate with the experts. And yeah, so that's basically it. Thank you very much.
Thank you. So we welcome our next presenter, who will be presenting on the expert working group presentation on standardizing LCAs for proteins by Dr. Raymond Obey from University of Manchester.
Thank you. So this presentation is more of a pitch rather than a presentation of what we've done in the working group. And I'll start the pitch like so. A couple of weeks ago, Matt Hancock was sat in front of a committee, and they were asking about what strategies he used to address the COVID-19 pandemic. And he referred to a 2011 influenza strategy. As shocking as that seems, despite the fact that we have tons of different research output out there that can be used to address the challenge that we faced, the government relied on the influenza strategy because it appeared that that's the only strategy where there was research consensus. And so the idea is that research consensus around measurements in particular is quite important. And all the talks we've heard so far about life cycle impacts revolve around LCAs. Because the only way I can tell that one product is better than the other, or one intervention will suffice better than another, is if I can demonstrate through life cycle impact assessment the actual impact of product A compared to product B. But the question is even more complex than that, because when we are talking about impact, impacts are not only to do with products, but they're also to do with the actors themselves, the processes they engage in, and the communities they engage with. So the idea of creating a harmonized view of LCAs from the research community's perspective is crucial. If for any other reason, for the fact that if we left it up to governments, they will go with event-based thinking. And we've seen that with the new push towards electric vehicles. The LCAs that support that type of systemic change are, first of all, not publicly available. The methodologies are not publicly verifiable, although the organizations are well known, like CCC. As academic communities, we can't quite verify what they're saying. So when they tell us one system is better than the other, like EVs are better than conventional vehicles, we have to take their word for it, unless we do something ourselves around harmonizing what we report. Now, harmonization is a big word, but where we come at it from the food perspective, is from this idea of alternatives. The idea that certain food
items are sustainable alternatives, as we heard earlier today from one of the plenary speeches. But what is an alternative? An alternative to what exactly? Usually LCAs are taken from the point of view of looking for alternative products. But as we know, environmental impacts can come in different forms. So when we're thinking about harmonizing LCAs, we must be thinking slightly beyond just the LCA around the product, but also consider things like that, the LCA around the technologies. If someone says shifting from meat to alternative proteins is a better way to go, we might be able to prove that the impact on the environment of growing a particular insect is better than growing cattle. But how about the technologies that we need to produce it? LCAs are also about processes. Underpinning any LCA is not just the product, but the life cycle of the processes involved. And finally, the one that is actually missing from the literature entirely is LCAs around governance. As we change from one authority to the other, from one business model to the other, the impact on our environment changes. So as a research community, part of this working group, one of the ideas we're trying to explore is, can we move the discourse around life cycle assessment beyond just looking at products to looking at a combination of these things? LCAs around products, processes, technologies, and governance, to find how these intersect. These thoughts came from one of the projects I, Sonal, and Paulina and our colleagues from the network worked on with the WWF around protein substitution. Now, similar to the debate around substituting meat with alternative meat, there was a debate put forward by WWF that our food problem is largely driven by retailers pushing a lot of meat on us. Currently, they hold around 90% meat and animal protein compared to plant protein. And the debate was, can we get the industry to tell us what it will take to move to 50% meat and 50% plant produce? Now, we did an extensive futures studies, which involved several panel expert meetings, several extensive systematic reviews of all the different methodologies, including LCAs, socio-technical analysis, techno-economic analysis, and so on. And what we found was that the answers aren't quite as simple. Such a shift doesn't take looking at the product alone, as conventional systems will allow us believe. And if we don't take the matters into our own hands as researchers to define to the people in authority what we think these standards should be, then they'll push it down on us and tell us that by 2040, we all have to switch to electric vehicles. And they'll show us LCAs with non-verifiable methodologies, and we'll have to accept it. Why is this a challenge? Chicken used to be, currently is considered one of the biggest problems, but it used to be the solution to the problem. At one point, there was scientific consensus just after the World War that we had to grow our chickens even more so that we can tackle the hunger problem. Fertilizers are today a big problem. We had scientific consensus just after the World War. I think Haber in 1918 won the Nobel Prize for it. He was considered the food czar because he saved the world from mass extinction due to hunger. And now we're facing a similar challenge where the things that brought us respite in the past, chicken and fertilizers, are causing us trouble. And if we don't come up with a comprehensive way of deciding what the next step is, if we just took the knee-jerk reaction to say, well, the product analysis show us that meat or insects are better than meat, therefore switch to insects, we might run into the same sort of problem we're facing now, 50 years from now. So what are we wanting to do? We're wanting to engage as many people in a number of different debates. The first one is, how do we harmonize LCAs around methodologies, data, impact assessment, sector-specific guidelines, reporting and communication, software tools, and so on. The next debate is, how do we harmonize scope? By harmonize, we don't mean that everyone must agree to use one scope, but at least the accounting around each scope must be agreeable by industry experts. So that when we say we are doing cradle to hospitality, everyone in the industry agrees with the metrics we are using, the measures, and the analyses. Typical example from our research in the food industry, we find we did a systematic review of all the literature around the different LCAs to do with meat, and we found 3 categories. When it comes to feed LCAs, a range of different scopes and a range of different functional units are used. Part of what we want to do in the working group is to engage the industry experts to find out which of these functional units are actually relevant for industry. Because for us to arrive at consensus, we have to know what exactly they want measuring. This is researchers' take on what we think is important, but it has to align with what the industry thinks is important. The same thing happens when you look at whole system LCAs. The scope, very different. The functional units, very different. A similar issue with waste LCAs. So part of what we want to do in our working group, we already have 4 members in the group, and we are appealing for more to join, because I recognize that there's quite a lot of you with expertise in different areas that can contribute to this group. I and Sona will bring the supply chain angle, but we have Gail, who's in the standards area, and we have Katie, who's an LC expert around food, but we need methodology-specific experts, particularly people who work around economic system evaluations, socioeconomic system evaluations, nutrition LCAs, and so on. I'll close by saying what we want is to come up with something that industry agrees upon. Because in the future, we'll have to be making these comparisons, and at a certain point, it might be comparisons that mean life or death. At this point, we're comparing, do we go with meat or do we go with insects? But when something sudden happens, just as we saw with COVID, policymakers will have to fall upon what is available. And currently, we don't have any harmonized standards. We don't even have agreement in the food industry around what we need to measure when we're talking about LCAs. And as meat has been implicated as the most dangerous player in the food sector with respect to carbon impact, it's important that we begin by harmonizing LCAs around measuring the impact of proteins like meat and other alternatives. Thank you.
Thank you, Ray, for such an insightful presentation. And next, Professor Sonal Chaudhary is going to talk about SFN Plus Strategy Partnership Project. And over to you, Sonal.
Yeah, I'm just wondering whether this would be a good time for everyone to take questions from the existing speakers, and maybe I could do the presentation in the next session after coffee, because we are already running a bit late. And we have Kiran, who was supposed to be here at 4:30. She might be here by 4:40. So she's running a bit late. So is it a good idea to just give the floor to all the speakers who have presented so far and see how many questions we have from all of you? Yeah. Ray, this is nothing against you, because I think it was really important to hear the standardization and the need for the industry. So we give you a little bit of more time to explain.
I was so into that, I forgot that.
Thank you for doing that. But yeah, we'll open the floor for questions, and then.
Yeah, may I invite all the presenters to come over here on the stage too, so that questions can be answered.
There's one more mic? Yeah, okay. Question.
So yeah, so here first question, and it is for.
I saw Manish on the screen, so I wanted to ask a question on the FPOs. You spoke about the FPO.
Yeah.
Of any collateral assets with the FPOs. That's one of the constraints why the financial institutions are not lending any money to the FPOs. So I just wish to know your thoughts on that. Thank you.
Sorry, can you repeat the question, please, about the collateral assets?
The FPOs in most parts of India, they do not have the collateral assets. So that's how the financial institutions do not lend them any loan and any money.
Yeah.
Yeah.
Okay,
That's
some thoughts on that.
observation. Yeah, that's just an observation. So
Yeah, I think even a step before, more than the assets, financial institutions don't have an understanding about what assets are needed by the FPO and what assets are they using or renting. So for example, if you look at any FPO combined, all the farmers, how many tractor hours are they using, or how many pumping set hours are they using, or how many threshers or crushing mill hours they're using. It's not in data which is readily available, and that's why we don't even know their need. So in our initial prototype, we have built a version which is like similar to an Uber taxi kind of a model. So there is a functionality where people, when they are hiring something, they can hire via the FPOs. And that's where we will be able to collect the data, and we are trying to do that and show that, okay, overall in a year, this is the kind of asset requirements. And that is where we think that it will open up the opportunity for asset financing banks, as well as people who would like to just put their assets on rent. So I think there is a step before where we establish the need or the total requirement at the moment, if that makes sense.
So our next question is you.
My question goes to Raymond. Very impressive talk. What I'm just wondering is, what's your strategy? Is it you will have an outcome of an academic publication, so that is in the public domain, or are you actually looking for a more direct route to go to the policymakers?
So that's a good question. We're thinking about a combination of routes. So the first one, of course, is to get the academic piece right. Like I said, before you talk to policymakers, there has to be a sense of consensus among the academic communities. And just to preface, when we did the work with WWF, we liaised with pretty much all the big retailers in the UK, all the largest food producers, and the biggest players. Yeah, we liaised with the biggest players and the policymakers. And what seemed to come across was, we know that all these methodologies exist, but you yourselves don't agree on what methodologies you need to apply, and when you're making these comparisons. And so the first step for us is, if we targeted, and the reason we're thinking protein strategy, so working with WWF, we targeted an industry, protein, we begin with meat, we come up with think of it as a go-to manual, if you like, for what you need to do if you wanted to do meat LCA, what type of functional unit, what type of goal scope, and so on, and what data, what regulations, what methodologies, the whole 9 yards, so that when an industry wants to compare, say, their meat with an alternative product, they would have that as the scientific reference. The second leg of it would be the policy engagement bit, because it's a network and it's going to involve inputs from several experts, and as well as industry players, because we would validate this with industry players. The idea would be to push for a policy drive around a UK protein strategy. And part of the work we did with WWF involved scientists and food scientists, and they are thinking about coming up with a compendium of proteins to compare them based on amino acids, because currently comparing 10 grams of chicken to 10 grams of beans is a pointless comparison. And so we need a more refined way of comparing. And science is there, but the compendium is still missing. And so we're trying to initiate the first steps towards building that compendium of all the type of data, all the type of inputs we need for protein comparisons, because that's what we'll be doing a lot of in the future.
Okay, so we have a question here from Jeff.
Yeah, I agree with what you just said, but you put that word on the slide, didn't you? governance.
Yeah.
And in my personal view, I wouldn't wait. I've seen similar things in radiotherapy, and they had governance groups there that included patients, and included industry, included academia, and included the clinicians.
Yeah.
And they didn't wait. They pushed on. I think you should do what you do. I know it's easy for me to dish out tasks. I'm sorry, but I wouldn't wait, because what you just said is going to take forever, isn't it?
Yeah.
Everyone's going to agree. No, they're not. I think in some ways, forgive me, I think some organizations do like a bit of chaos because they can move unchallenged. And I think what you're doing is great. And I wasn't expecting this. But it's so dry as a subject. But I think governance is key.
Okay, so we have our next question here.
Yeah, actually, I was going to build on the same point. And just a little bit of Goethe, just to get us going in the afternoon. I think you need to start. And once you begin, then you'll get a response. If you wait, you'll wait forever. So go with Goethe, go with begin what you can imagine, and lead. Don't wait.
Are you finding it? Yeah.
Why do you have to bring it down to just to the very top of philosophy and you sully it with cash?
So we have a next question from here.
Yeah, thank you, mine goes to Tim. I know we spoke, Tim, the fisherman, one the fishing project. I think also a similar person presented online. I remember who that was, of the Kenyan perspective. This is exciting, but you and I know the environment we're dealing with in the prototype that you bring to cool fish and ensure that it's safe. So what strategy do you have in terms of making this happen, the model that you bring? Because I imagine if we're struggling for people to afford to buy, I don't now know how even the hawkers can afford to get this prototype to ensure that fish is cooled in the supply chain. Just if you may share, or if you have some ideas in mind.
Thanks for the very tough question, because it comes down to money, right? You're quite right. I mean, that's one of the challenges that we find is actually some of these technologies, they're available, but they're not adopted. And often that comes down to a question of cost. However, I think there are new models coming up. I mean, I would put it back to you about your model, that the triple F. I think that type of thing where you're aggregating products allows people to buy into some of these innovations that are designed to be cost effective. You know, it's that lean idea of innovation coming through. And I've seen lots of very innovative solutions that deal with the fact that we've got a product that's highly perishable. How do we actually tackle this and bring it to the market? The challenge is you would have seen some of in the video, some of the smoked fish, some of the dried fish. The problem with that is it's the quality goes right down. And actually you're providing customers with a product that's not great quality in a market where they desperately need those micronutrients and that protein, those essential amino acids. So if we can get some of these technologies and we can aggregate them for some of the models that we've seen, remember these are extremely expensive solutions, then I think it is possible. But thanks for the question.
Okay, so being conscious of time, so we'll be taking only a couple of more questions. And yeah, the next question is from.
So yeah, I have a couple of questions. So okay, I'll keep them short. So I was wondering with regards to the IoT cold box, whether you have considered any renewable energy solutions to power up your battery, like lightweighted photovoltaic panels on your lid.
Is Ahmed online?
Yeah, I am available. Yeah.
Maybe I'll pass.
Okay. Yeah. Thank you for this very good question, actually. So the answer is generally yes, we consider this kind of thing. But for the time, because the time was very tight and the tight budget for this project, we didn't include this at this stage. We now collaborate with another company in the UK while we develop a slightly bigger box with IoT tracking and with PV panels actually to make one holistic solution and one holistic standalone box to be charged, run automatically, to be modular. But the challenge is what would be the sweet size that will suit the fish farmers. But this is why we do research, why we bid for projects to answer these questions. But the answer is yes, but not for this project.
So maybe it's something to see in the future then.
Yeah, hopefully, yeah.
Awesome. And I do have one more question. Awesome. To Raymond. So I was wondering, okay, you could achieve harmonizing LCAs within a country level with you have a less variety of different cultural backgrounds, but how do you harmonize LCAs worldwide when you have different cultural backgrounds, and how you communicate that, okay, this LCA seems to be better, so you could consume something that you are not accustomed to consume? So that is my...
Yeah, I think that's a very good question. So the idea behind harmonizing LCAs came because of our interaction with the retailers, the biggest retailers. And it made it obvious to us how powerful they are in this debate about what we eat. Recently, they started pushing for alternative proteins, and they're trying to market these alternative proteins as better. And they're using LCAs. In fact, we were part of the review committee for one of the largest retailers who put out an LCA for an alternative product that got rejected by the review body because it didn't adhere to certain standards, so to speak. So what this showed us was, if we can get the main actors, the big players, let's call them the Asda's, Tesco's of this world, if we can get them to come together around the table and agree on what a consensus methodology is, then we've started the worldwide campaign, because they're already putting out these comparisons. I'm sure you've seen ads everywhere of this meat is better than that, and that is better than that. If the underpinning methodology is one that they all accept, then we can start the worldwide campaign. But like Jeff mentioned, I don't think we should start out trying to reach the world. If we start with a group that can create critical mass around a particular approach, then that's the best way to go. And we think particularly around meat, because it's now the culprit, and there'll be quite a lot of comparisons with meat. If we can get some kind of standard way of looking at meat, right from the scope, the functional unit, all the way down to the analyses, and get the actors involved to agree. We're hoping to organize a few expert workshops to do that. And we think that that will be the beginning to encroaching into the global space. I would like you to join.
Okay, so any more question? One last question? No more questions.
Can I just have one final comment? Digital platform.
Yeah.
Yeah, thank you for presenting on digital platforms to both Sarang and Anurag. Our idea for that expert working group was also to look into, and I think you are going to look into the different sort of data types and the methodology for collecting those data. And can we actually have some standardized operating protocols that we can produce for different countries, looking into at least one similar objective. So objective could be either looking into increasing the productivity at the farm, or the objective could be connecting farmers to the market. What sort of data do we need? How should it be collected? How often it should be collected? So that we have fantastic data scientists here. We don't spend much time in cleaning the data. Can we see something of that sort coming from your expert working group?
Yeah. Well, yeah, that's I would say a right direction on this particular project on the digital platform. Because say what's coming out very clearly is that more and more platforms are coming, and what Anurag already had said, that they had been across the agri ecosystem, food and agri ecosystem, right from the input to the output. There's already a lot of platforms going on, and there's there's a clear need of open network data, which actually can be shared with the research and academics, but more importantly also with the other stakeholders. Because see what we are working is also on the lack of access on information. So lack of access on information is not just for the farmers, but for all the stakeholders. And certainly we can build on those, what you said is a standard protocols, certainly would make available the data, and also the processing, which would be the second part of it, which Dr. Jens is already has been supporting us on that.
Yeah, from our perspective, we wanted to look at that which ones are really successful and what is the underlying story, why are they successful. So probably this will give us a better insight that what really works in the market, because there's a huge disconnect what people are trying to sell or provide and what people actually need.
Yeah.
So if we could just bridge that understanding, then probably we'll be able to answer a question: what data, what frequency, and where to find it.
Thank you.
Okay, thank you everyone for this wonderful session. Special thank you to all presenters. Now I can understand the session was heavy with information and insights after a heavy lunch. Now we should, without wasting time, we should break for coffee. And please everyone come back around 3:35 here, because Pro Vice Chancellor Kiran will be addressing at 3.
At 4:40, but before that, we will have a good amount of presentation from the funding bodies. We are all now looking forward to what sort of funding availability is there, so that we can start exploring, we can bring our heads together and hopefully collaboratively work together for some one or more proposals. So yeah, please enjoy your coffee and to come back. Thank you.